Good morning, everyone.
A house there.
Yeah.
Okay, so I think we're ready to get started. Lindsay, would you like to kick us off?
Absolutely. Good morning, everyone. Welcome to the January 9th Tank Waste Stewardship and Treatment Committee meeting. My name is Lindsay Summers and I'm the DDFO for the Hanford site. As a reminder, this meeting will be in accordance with the requirements of the Federal Advisory Committee Act. I would like to remind everyone to assume noble intent. I appreciate your attendance today and I look forward to the robust meeting. So Josh?
Thank you. As a reminder, these meetings are recorded and they will be posted to the Hanford site YouTube, link from hanford.gov. We do keep attendance for these meetings, so if you haven't already, please sign in at the table over there. Those online are asked to enter their names and organizations into chat. You can find bathrooms out these doors, to the right and around the corner, underneath the stairs. Generally, everyone's asked to listen for understanding, assume noble intent, keep your phones on silent, and generally adhere to good meeting protocols. Rob, would you like to provide us an agenda review?
Sure.
And
Sure.
give us a recap?
I'd like to welcome everybody to the meeting here. Lindsay's worked real hard to try to obtain some SME support for the presentations. I understand it's going to be real good. I want to give a little short recap on the last 3 years, essentially, of our HAB meetings with regards to tank integrity. There's a slide that'll appear on the screen.
We'll come to the agenda in a minute, so
Introductions
opening
first?
remarks, yes, exactly.
I'm sorry. Let's introduce everybody here. And so my name is Rob Davis and I represent the city of Pasco.
Chris Sutton, public at large.
Mia Burke, Hanford Challenge.
Susan Coleman, public at large.
Jacob Reynolds, non-union, non-management. Jim Alzheimer, engineer at ecology.
Brian Miller, ecology.
Laura Caulfield, Detainx, contractor DOE.
Lindsay Summers, DOE.
Larry Brand, community at large.
Steve Anderson, Franklin and Grant County representative. Matt Hendrickson, Oregon Department of Energy.
Chuck Opresti, legal voters.
Judy Talbot, head facilitation team, and before we wrap up in the room, we'll be calling people online with your first name and ask you to introduce yourselves.
I'm Josh Patton. I'll be serving as facilitator for this meeting.
I'm Rogers, Washington State Department of Health.
Eric Nelson, DOE Officer of Protection.
Thank you. Online, Megan? Megan Perkins.
Megan Perkins, Department of Health.
Thank you.
Bob Quirk.
Bob Quirk, Observer.
Ambika.
Ambika Chakraborty, Ecology.
Thank you. Dan.
Dan Solch, member of the public.
Dave.
Morning all, Dave DeSimone, engineer at ecology.
Thank you. Gabriel.
Gabriel Bonney, public, but with the NESPR stripe.
Thank you. Apologies if I get this wrong. Moses?
No, you got it right. Moses Guevara, Ecology.
Thank you. Destry?
Destry Henderson, Washington River Protection Solutions.
William?
Bill Hudson, Department of Ecology.
Jeff?
Jeff Wyatt, Oregon Hanford Cleanup Board.
Thank you. Joe?
Joe Matthew, public at large.
And Liz?
Liz Matson with Hanford Challenge. Good morning.
Thank you. Steve?
Steve Needles with the Department of Ecology.
And Simone?
I think we don't have anything.
Simone Anter, Columbia Riverkeeper.
This is one of those.
That concludes introductions. Thank you, everyone.
And so if you give me just a minute, we're going to turn to Rob, and I need to bring up his slide.
All right. Rob, would you like to start talking ahead of that?
Okay, well, like I said, is that starting last year, probably in September, I circulated through many of the tank waste members, asking them what important questions do you have about tanks or the tank integrity presentation. So I put that list together, I circulated around in December, and then I sent it to Lindsay I think in December. I think I gave you a copy of it, the list of the questions. Yeah, and then she's been working real hard trying to find some SMEs that can answer those questions or some of those questions. And so then I just quickly want to go through the last several years. We've had tank integrity is a really important aspect of the Hanford. And so we nearly have a presentation at least once a year, and in some cases, 2 or 3 presentations during the year. And because the tank integrity involves a lot of things, and a lot of things touch it, you know, including the leaking tanks and things of that sort. We had presentations 22 to 21. Here we had Summer Marnie Karthik came in and talked and gave us a really good presentation and the latest results from the inspection and the reports. Also talked there about the IQRPE report. A tank integrity draft document was put out for review in May. And we also had the leak strategies and the fact sheet from the B109. That became a real active meeting discussing that. Again, in November of 21, we had another contractor DOE presentation on the integrity program and how it fits in with the delivery of waste to the WTP. Then because of the leak issue there, we met and been looking at the proactive advice for the single shell pumping. So we have a leak in the single shell tank. We asked for some sort of a response out of DOE, some sort of plan. And then this last presentation we had was Fletcher came in and gave us the big picture approach to what he's doing. And I think, is Fletcher still the boss of the tanks? Delmar Noise, okay. And then but I have to point out that from 2013, 18, and 22, we issued advice from the committee. One in 13 was leaking tanks. And then when we end up with our double shell tank failure and leaking the double shell tank, the inner liner only. And so we had advice come out about the DST tank failures. And then in responding to the leaking tank, waste tanks, the 313 was the last piece of advice that we came out. I'd like to make sure everybody understands that we have a very active webpage, or the Ecology and DOE have put a really great presentation with a lot of history in it. A lot of these presentations are full of pictures and especially on the inside of the tanks, what it's like before it's totally clean and what it's like after it's clean. Other presentations talked about some of the non-destructive testing and things of that sort. And so, so we've been very active in this. And so if you feel like you're missing something, please check out the website. They've done a really good job of presenting them in there. They're easy to see, PowerPoint presentations, and it's almost as if they're giving it to you right there. So I really enjoy the active committee members in the Tank Waste Committee. And in the area of tanks, we have not been requested to issue any sort of advice at this time. But that's kind of, if it's a topic that's boiling up in you, let's discuss it. We'll go to Lindsay. Lindsay will say yay or nay or next year or whatever the thing is, but then we'll try to meet our needs if we ask them. So we have 2 presenters today, and they're in the back there. And so should I introduce them?
Sure.
I can introduce them.
Can we just pause for one moment?
Oh.
Ladies, is it possible to slide down and have the gentleman come to the table, because the people online will get a better view.
Maybe the sun coming through that door.
I'll grab the door, Rob, you're good.
Thanks.
Yeah, well, we're glad to see the sun though, right?
Oh, yeah.
That's a good thing.
Rob, only grab this door too?
Well, that one is the reflection on the straight in that. Eric is the first one up. So,
Yeah, no, thank you for having us. My name is Eric Nelson. I'm the program manager over at DOE Officer of Protection, responsible for the tank integrity program as well as technology development within that world. Alongside me is Jason Gunter, who is Washington River Protection Solutions Tank and Pipeline Integrity Program Manager. And yeah, we decided to share sort of what the program is and some of the technologies that we've been working on to help further it and push it, forward. I think we can just get into it if everyone's ready then. Yeah, great. So maybe move on to the next slide. So I think, as mentioned before, this is just a general overview of the program itself, as well as the technology development. I think you'll see throughout the presentation, the program is definitely not static. It's very much forward-looking, both based on the data we collect from our tanks, as well as looking out and seeing what other technology and inspection methodologies may exist that we can incorporate into our program. And we really want to give everyone here just a better understanding what that program looks like and where we're taking it. So next slide. Provide a brief overview of the tank farms themselves. The first series of tanks were the single shell tanks that were at the Hanford site. There were 149 of them built between 1944 and 1965. Different shapes and sizes for a lot of these, anywhere from 55,000 gallons to 1 million gallons. For point of reference, just to give you a sense of scale, when you look at a 1 million gallon tank, that would be a 75-foot diameter and well over 30 feet in height itself. So they're quite large, especially the 1 million gallon tanks. And then I believe on average they're about 7-10 feet underground from the top of the dome itself. They consist of a concrete shell, which contains a single shell, what we call the liner itself, which is a carbon steel liner that then has a waste stored within it. And that was the original design there. You can see in the graphic we have showing you the different capacities and types that we have within the single shell tanks fleet. From about the mid-60s up until the late 80s, we constructed double shell tanks at the Hanford site. You can think of that as like a tank within a tank. So you still have that concrete encasement with a carbon steel liner in it. And then within that carbon steel liner, there's another tank, which is also a carbon steel liner. That creates about a 2-foot gap between the two of them. And that gives us a lot of additional inspection capabilities, which I think you'll see in the presentation, having that additional accessibility that's not present in the single shell tanks. Nominally, the double shell tanks range in capacity from 1 to 1.25 million gallons, and we've got 28 of them across the Hanford site. Next slide. So, brief overview of the tank farms themselves. We tend to think of the tank farms as two separate areas. You have a west area as well as east area. You kind of see that based on the split down the middle there. A lot of our single shell tanks are in west area. You can kind of see the evergreen color, although we do have a fair amount in east area as well. For sense of scale here, it's about 7 miles from west area to east area, so certainly the drawing itself is not the scale, but it's a fair amount of distance between the two of them. You can see, generally speaking, to the flow sheet here, just for how the waste will eventually get handled and processed. It moves from the evergreen single shell tank farms into more of those lime green double shell tank farms that you see. So that's a process we call retrievals. From there, it's then processed through Tisker, which is located in AP farm in the bottom right corner of that map, and then sent on a waste treatment plan. So generally where the tank integrity program fits in all this is to help make sure that these tanks are around such that we can pull the waste from them, put them into the double shell tank system, and then eventually send it on to the waste treatment plant for disposal. Hanford's got a long mission, and so we're very proactive in terms of monitoring these tanks and making sure that these tanks can support the mission that we've got coming up. Next slide. So a little bit of history about the program itself. Really, this is really just a snapshot in time. Programs existed in one shape or another since the construction of the tanks themselves, but this is at least the recent history. You can see the double shell tanks. We incorporated ultrasonic testing, which we'll get into more here soon. That was in the mid-90s. Visual inspections are ubiquitous both throughout the double shell tank as well as the single shell tank program. Chemistry optimization is a unique capability that we have with the double shell tank system, as well as a structural integrity. So structural integrity, performing structural assessments is done for both the single shell tanks as well as the double shell tanks. One thing I'll highlight is you can see for under single shell tanks, you have something, it says stabilization and isolation. So that's part of the interim stabilization program that we did. That was a decades-long program that the department conducted where we removed all pumpable liquids from the double shell tank or single shell tank system and placed them into the double shell tank system. That concluded in the late 2000s, early 2010s. A couple other things I'll point out here. There's two bottom rows. You can see it says expert panels as well as integrity assessments. One of the key aspects of the program is we do solicit frequently input from external experts, both in academia, industry, national lab system, whatever it may be. We recognize that management of double shell or single shell tanks, there's tank systems are the way we go about inspecting them. There's industries built around this, and there's a lot of expertise out there that we like to tap into because of that. We're fortunate up here to have a tank integrity expert panel that helps provide us with independent perspective and guidance to help inform the direction we take the program in. Those experts are in everything from corrosion chemistry to structural integrity, regulatory experts as well, kind of covering the whole gamut of aspects of the tank integrity program. And then finally, the integrity assessments, those are periodic IQRP, so independent qualified professional registered engineer. A little bit of a mouthful, but those are independent assessments where we bring in external review teams, engineering review teams, to assess the integrity of the systems themselves. That's done both for the single shell tanks as well as the double shell tanks. We'll go on to the next slide. All right, so what do these programs, the nuts and bolts of them look like? So for the single shell tanks, the key point is to confirm safe storage of the waste and support of retrievals, making sure that we can support retrievals for when we do get into those tank farms. Those are four main aspects of that, starting with the in-tank visual inspections. You can see some of those images down there in the bottom left photo. These give us a really great sense of what the waste surface looks like of the tank, as well as the sidewall that may be exposed. You can see either that carbon steel liner that I mentioned earlier. We also take advantage of these to inspect the dome itself. So we'll point the camera up. We've got really great hand tilt zoom capabilities to look all around the tank itself, as well as with some of the lighting capabilities we had before. If you go back to the 80s, it was very, very difficult to get good lighting within these systems. And now we're able to basically look straight across a 75-foot diameter tank from one point to another with the current lighting systems we have with no problem. So it's come a long, long way, reduced the amount of time that it takes to perform these inspections, as well as helps get us better quality data itself. And we'll go into some of what those technology improvements have been with Jason here in a little bit as well. Waste monitoring is something that we do routinely in the program. So that's done through two main methods. We have something called an NRAP, which is basically just a bobber that you can think of. It sits on a liquid waste surface, and as that waste surface may change, if it does change, we can track that with the bobber. We do have another methodology called liquid observation wells. So those are, that's another tool that we'll use in specific scenarios where there may not be a liquid waste surface at the top of the tank, but there may be liquids that are entrained or below the surface that we can track with the liquid observation well. And that's done routinely, both informed program as well as meet regulatory requirements. Structural analysis, another key component of the program, really focused a lot on tank domes, understanding what the domes are doing. Just kind of a few different ways we go about assessing that. We have a routine dome deflection surveys that we perform. So we'll look at, we have above ground stakes that are connected to the dome. We look for any sort of changes and deflections in the elevation of those stakes that may inform the condition of the dome itself. Thankfully, we haven't really seen anything alarming with those inspections. That's good. But we also complement that with our laser scans, as well as structural analyses that we perform. We'll work with PNNL as well as other structural experts, take laser scans from the inside these tanks, understand what's happening to the concrete itself on the dome, how that may be changing, and then assess that. And then the integrity assessment, I think you heard me mention it earlier, but those are those IQRP assessments that we perform. I think right now the single shell tanks are performed on IQRP recommended a 16-year frequency, so that'll be sometime in the early 2030s for that next assessment. Moving on to the next slide. The double shell tank integrity program. So I mentioned it earlier, but the double shell tanks have that about a 2-foot gap between the primary tank as well as the secondary tank. We call that an annulus. It gives us a lot more flexibility in our inspection capabilities for these tanks. Just another access point, really. We'll take advantage of that for visual inspection, similar to the single shell tanks. We'll do that with the double shell tanks, inspect the annulus of those spaces. Ultrasonic testing is one of the unique capabilities for the double shell tanks. That's where we'll stick a robotic crawler into the tank, which will magnetically couple to the sidewall of the primary tank and actually traverse the sidewall of the primary tank and take scans via ultrasonic processes and get us actual thickness measurements of the material. So we can take that data and then track and trend it over time and understand, are we seeing any thinning in the tank sidewall? Is it staying nominally, are we seeing nominal thickness, whatever it may be. That gives us a lot of really great data for how, if we're seeing any potential corrosion mechanisms of that primary tank wall. We'll also do it for the secondary tank as well. Waste monitoring, pretty much the same deal as the single shell tank system. The noted addition here is that even though we don't have waste in that annulus space, we do have leak detection tools, basically those NRAPs that I mentioned earlier, to help detect the leak. There was one from the primary to the secondary. Waste chemistry control, so that is something that's a little more unique here, since a lot of the double shell tank waste is bulk liquid. We're able to blend it and mix it with corrosion inhibiting chemicals that allow us to, there's been a whole lot of science done, both through the tank integrity expert panel as well as in other forums that look at hampered tank waste and I'm trying to understand corrosion tied to that. We're able to perform these chemistry additions. Typically that means raising the pH of the waste itself to inhibit that corrosion. It just gives us an additional flexibility. Structural analysis, much similar to what we do with the single shell tank system, as well as integrity assessments, which I mentioned earlier. A few images down here below before we move on to the next slide. You can see down in the bottom left, this is comes out of our visual inspections, those annual visual inspections. Uniquely though, this is of what we call the refractory pad. So there's a concrete pad that primary tank sits on with these air slots that are carved into it. That was by design to help promote cooling initially when these tanks were constructed, help give uniform airflow beneath the tanks. They were never designed to have cameras inserted into them, but we were very interested in the condition of the bottom of that primary tank, so we developed the capability to stick, you can think of it almost like a snake robot camera down those air slots, which they traverse the diameters 75 feet. We're going over 30 feet towards the center of the tank in a lot of these air slots to get really good data as to what we're seeing on the bottom of the primary tank there. The waste core sampler, that's some of the waste sampling we do that helps inform the corrosion chemistry that we do out here at site. You take the waste, and you sample it, that will give you these conditions. And then you got another, I think on the far right, there's just a visual image for what their UT crawler looks like. So those are the two programs at high level. I'm going to turn it over to Jason here, and he'll be able to speak to some of the new technologies that have been developed as well as deployed as part of this program.
Thank you, Eric. I'm Jason Gutcher, just introduced again. I manage the tank and pipeline integrity and tank monitoring group for WRPS. Work for you. We obviously manage the tank farms out there. We conduct all the inspections that are part of these programs that Eric just gave you the rundown on. We've been doing that for quite a long time. I've been in that particular group as an employee in the group for about 11 or 12 years, and I've only been the manager for the last year or so in that organization. I was with the HAB last year rather, so thanks for inviting me back and Eric back to come talk to you again. I want to pause real quick though, between the program overview and the details of the new inspections to ask for any questions from the audience or anything you guys have that you found interesting about the first part of the briefing there. Any questions you might have, we can discuss.
I did have a couple people in queue.
Sure.
Starting with Dave.
The question was, how often does the integrity panel meet? And then as a matter of process, we normally go through the whole presentation, ask for agency perspectives, and then open.
That's fine. Okay, so I will address that, then we'll move on with the briefing, okay?
Okay.
So we meet, the tank integrity district panel meets on a bi-weekly basis for elements of it, which is our corrosion control section of the panel. There are several areas of the panel, including non-destructive examination, corrosion, chemistry, structural, and the like. The corrosion piece of that meets every 2 weeks. Otherwise, the full panel meets twice a year. And we do coordinate with them and the chair of the panel as needed throughout the year on a more informal basis as well. So that's an ongoing interaction throughout the entire year, essentially, as needed. So discussing just this new technology, Eric mentioned the work we do in terms of inspections, both visual and volumetric inspection. Volumetric, of course, here means measuring wall thickness, looking for any evidence of corrosion damage or failure imminent for structures, systems, components, whether it's a tank or a transfer line or a concrete structure or a carbon steel structure. We're looking for all those areas of degradation across the systems that we examine with our inspections. We use various tools to do that. A lot of cameras, as you can probably imagine, as well as robotic tools. The challenge we face oftentimes with our inspections is they're remote. We don't have direct access to walk up to and access the surface to go conduct the inspection. So we need a tool that allows us to get there from a distance, and oftentimes a significant distance away, where we're not putting our staff or others involved in harm's way, right? So we use cameras and we use laser scan devices. We use visual inspection in accordance with our inspection program, and then we also use NDE, which is oftentimes ultrasonic testing, which is measuring the wall thickness that I talked about. Some of the tools we've been developing over the course of the last decade or so that I've been involved in the program really includes better technologies for cameras. So as Eric mentioned, we used to have lower quality lighting conditions. We used to use analog cameras and record in an analog manner. Over the course of the last several years, we've transitioned to better LED lighting that's much brighter. We've transitioned to digital recording of video footage, which has a lot of advantages for us. Largely, you can probably imagine, we've all been using digital cameras for a long time since we were all, much younger, but it's much more difficult to get those technologies employed in an industrial setting like we have, where you're, relying on doing the inspection from, say, 600 feet away in some cases, and you have a lot more challenges involved other than just like a point-and-shoot camera you might have in your cell phone. So we have these tools now that allow us to do digital recording of this footage with much better lighting capability and much higher resolution than previously available. And that's had a lot of benefits for us in both time to do those inspections, to receive the information back from the field to evaluate, and to do more of them essentially than we have in the past at a much faster rate. So Eric mentioned we do visual inspections, we do volumetric inspections. I'll talk just briefly about how often we do those things. So we do visual inspections inside the annulus of the double shell tanks on a periodicity of 3 years right now, which is much faster than it used to be. It used to be 5 or 7 years, depending on the tank. And then we do visual inspection inside the single shell tanks on a 10-year frequency, of which those are 149 of those. So we end up touching about 15 tanks per year with visual inspection inside the SSTs. That gives us an understanding of what's going on. Monitoring largely, like Eric mentioned, the structure, the concrete structure, the steel liner in the tank, any in-tank equipment that's in those locations, and having better tools to do that monitoring helps a lot. When we talk about doing volumetric inspection, we do deployment of those robotic tools on an 8 to 10 year frequency for the double shell tanks in that annulus space, and we're able to go measure the walls in these areas and then trend any degradation we might observe. And the purpose of that volumetric inspection is largely to characterize the effectiveness of our chemistry control programs. We have ongoing sampling programs and chemistry control adjustments to the TWST waste to see that it stays in a condition that's favorable for the carbon steel corrosion that it's contained by. And if our program detects any evidence that it's not the case, that it's being inhibited, we can take actions in advance of failure and prolong the life of those assets, which is our objective. So in terms of development of better tools, through findings in the discussions of the program or observations and data we gather, we needed better cameras, we needed better volumetric inspection capabilities. So we're looking at ways to inspect the tank bottoms of the double shell tanks. That's an area that's very challenging to access, as you can probably imagine. Eric described the configuration really as a concrete structure that provides the structural integrity, then a secondary liner that's just a carbon steel liner that collects any potential leakage from the primary tank. And then there's a primary tank inside that rests on this refractory or concrete pad, like you see in the top right picture on this slide. That pad has slots in it, and it also provides us access to deploy NDE tools beyond just visual inspection capability. So we I've been deploying cameras in those slots since 2018 or so. That's when we started doing that. We've done on the order of about 17 tanks so far of the 28 in the DST fleet. And we're in the process and have been in the process of developing technologies to go and volumetrically characterize that space, which means we're trying to find any evidence of degradation. If there is localized attack, corrosion, localized pitting corrosion, for example, or a crack in the tank bottom, or any general wall thinning maybe in the tank bottom, we'll receive back like sonar a reflection from that degradation by putting tools at the outside perimeter in the annulus space where we can deploy them, or even by sending tools under in the air slots that can do more localized inspection and measure for those types of things. So those are areas of our current development that we're working on that are in various stages of completion with support from national laboratories like PNL and various experts across the country actually. In Texas and over in Pennsylvania as well, a couple of folks that are leaders in that technology. Beyond just inspecting and monitoring though, there's a lot of effort going on to potentially repair degradation that's found. You'd like to be able to go into an annulus of a double shell tank and apply more material to the surface to build it up and provide yourself more corrosion allowance. That's a term we use oftentimes in integrity programs and in societies like ASME is what's your future corrosion allowance for your structure? That's how you know you're fit for use or not. If you have enough wall thickness to support leak integrity and structural integrity, you can keep operating. And so to prolong asset life, it stands to reason that we should have a way to go in there and add that when it's not there previously or the grade that corrodes away over time. So our Chief Technology Office and DOE is supportive of this, of course, is looking at technologies to go and do a technology called cold spray. Cold spray is a low energy, low temperature process by which you can remotely basically ablate a surface with particles of carbon steel or stainless steel or depending on the material of the substrate you're working with and build up a layer of material corrosion allowance on that surface. And you could do this, say, in an area where you have localized pitting to provide yourself more leak integrity. You could do it on a broader scale and provide yourself more structural integrity and the like. It's often done in other areas that are much more easily to access. You can, as you can probably imagine, you need to repair corrosion in an accessible structure. In our case, we're looking at deploying it via remote technologies. So a robotic crawler like we use now, or potentially other newer robotic crawlers we have to develop to deliver given the weights and the sizes of things, it might make sense to do that. So that's something that we've been testing in our mock-up facility here in town and have been working with a couple of vendors to develop through a couple of years of work right now. So that shows promise and is something we could consider using in the future as that testing continues and we get down the further phases of technology readiness for it. Just some tools though, on the next slide, if you would please, that we use across the program. This represents sort of the fleet of options we have now. And you can see the options we have and what we can utilize to go and gather data in the tanks as we have them. That really includes elements of visual inspections and ultrasonic testing inspections. The top left picture there is just a basic borescope. That's GE Mentor IQ is the model of it if you're curious. We use those to great effect in some areas where we have limited access, where the hole to enter a space is very small. Those get down to the 8mm size or so in terms of diameter. So then they have onboard lighting and kind of articulation capability. We use tools like that in several areas where we need to go get a visual inside of a structure. We've used them in our evaporator facility and to go inside a reboiler through a little well lit. We've used them to go down inside our transfer lines to look inside their encasements on a periodic basis. So those are the kind of reasons we'd have a tool like that in our toolbox. The other top two pictures there show a crawler we use to do those volumetric inspections inside the double shell tank annulus space. That's called a Force AGS2 if you're curious. It's a tool we've used for many decades now. It's been slowly developed and improved over time, with better wheels, for example, and better appendages for the front that we can use to do inspections. The tool you see in the top right picture is a brushing device that's added to the front of the crawler. That front of the crawler we refer to as what's called a Y-arm. It has a motor that slides it back and forth side to side. Those brushes are pneumatically powered and they spin those wire wheels. And the reason you have that on there to begin with when you start to inspect the tank is you want to prepare the surface. You want to, create a nice clean surface for inspection so you get high quality data. So we spend the first part of our inspection regime for a double shell tank doing that in various strips and areas across the tank where we plan to go inspect with the UT transducers. And then once that's completed and we have these areas prepped for inspection, we take that tool out of the annulus space, modify it with the other Y-arm attachments, which allow us to do the ultrasonic testing inspection, which is a water couplant-based inspection where you're measuring the wall thickness and you're measuring with various different transducers to look for any evidence of direct wall thickness, as well as any evidence of cracking with what we call shear wave transducers. That's done repeatedly in those areas during each inspection. And all of our DSTs now, after this fiscal year, will have 3 rounds of inspection complete that we'll be able to compare between those iterations and show change in those areas if there is any over time. As part of those ultrasonic testing inspections, we leverage that time to also go down under in the air slots with visual inspection. The risers we need to do that and get into the annulus space are open during that time, so we use the deployment and that time spent in the annulus space to deploy other tools as well. That includes the crawler you see on the bottom left there. This is a tool we built and work with a vendor to deploy that deploys a camera down in those air slots, as Eric mentioned. So that's what that looks like. That's called the AMS 79, also from Force Technology. So it's got an arm at the end of it at the bottom you see there that has rollers and some pulleys that you press against the tether, and then you're able to drive that camera down the slot and push it to the slot from a remote location, which is not near where an operator would be able to do that, right? So as a little bit of context for that, the annulus space is about 40 feet tall. From the top of the annulus to grade is about 10 feet or so. So you have about, I'd say, 50 feet from where an operator is standing in the farm on gravel down to where this crawler is sitting at the bottom of that primary tank where we're deploying the tool. From the crawler position, or from the operator position at the top of the riser, it's being operated another 600 feet or 400 to 600 feet or so away in a trailer outside the tank farm. So we're operating it and watching it with cameras in the annulus space of the DST from a monitor and a trailer. And we are able to make manipulations and maneuvers and drive it around and deploy the camera, which is the picture on the, just one to the right of that crawler. That's a Wohler GIS 350, which has pan-tilt capability and some onboard lighting. That could be any camera though, if it's appropriate size and has the appropriate rigidity to make the trip. We are looking at all the different options for cameras we can utilize in this, and the tool is modular enough it can deploy many different types of cameras based on the diameter of those tethers and the like. So that's a nice feature of the program we have that's only been around for the last, I'd say, 5 years or so. And we've been deploying it routinely as part of all those UT inspections we do in those years, which results in about 4 UT inspections per year right now in each 4 different tanks. And then I mentioned cameras. The camera there, the visual inspection camera shown, is a GE product. That's a PTZ70. We use that for a long time here at Hanford. That's one of the legacy cameras we used to have. The camera on the prior slide actually is one of the newer ones we've developed and are now using as part of the inspection programs to give us higher quality, higher resolution imagery. And just another neat tool, the last one on the bottom right there is a product called a Mag HD. That's a magnetic crawler as well. Has a panning head on it for the high resolution camera, 1080p camera, onboard lighting. You see if you look close enough, it's got both spotlights and floodlights. So we're able to get some really good lighting and high quality imagery in the annulus space of the DST. And notable in this picture, the top right picture, that shows the brush crawler on the wall. That picture was taken with the Mag HD on the alternative wall in the annulus space. So we're often doing some composite inspections here with multiple tools at the same time to give ourselves that operational awareness of what's going on in that space. And one other neat feature of the Mag HD crawler there on the bottom right is it's got some laser scanning or laser line measurement capability. So it projects lines in front of it and you can kind of relative measure things in the annulus space, which is come in handy several times while we're navigating around in that space. So that's it for tools we have. Just lastly, talk about key takeaways, and then, like I said, we can move on to further discussion if anybody's got any questions. And we've been using these inspection programs to monitor the tanks for many decades, as Eric mentioned, easily since the 90s. Prior to that, certainly we're doing visual inspections and taking still images inside the tanks as technology allowed. Now we, of course, have a more regimented program that we execute that has a lot better tools than previously available. That's decades of experience that we've been gaining, and we have all that body of knowledge available to reference when we make decisions about any changes that have been ongoing in those regions of inspection, whether it's in the annulus of a DST or in the primary tank of an SST. They're always changing and evolving and getting better is the other key point I wanted to share, right? We've been improving the technologies and tools. We've been constantly looking for all this time, and we have all that information that we reference when we make decisions and make judgments about how we're going to proceed forward. And if we do find anything with our inspections, there's a natural tendency for that to feed back, and it's required that it feeds back into our next inspection and our frequencies of inspection, and also into where we need to go look beyond our current capabilities and develop technologies where we need to go and have additional tools to go characterize things we find. A good example of that would be degradation inside an SST, where you can't really deploy a robotic tool. You need a remote technology for doing non-destructive examination and measurement capability. That's where laser scanning starts to become a valuable tool, where you can deploy a mast-based tool or a tether-based tool down a riser into an SST space, and then deploy a laser scanning capability in a 360 fashion to measure the whole space and just see what you can find with that, where I can't just put an arm or a robotic crawler and drive to it necessarily, because I don't have the capability to do that. It's much more challenging. And all these activities, of course, are such that we maintain the mission and operate in a safe manner with the structures, existing components, whether it's an SST or DST or our transfer system or facilities like the evaporator or eventually WTP as well, which will have a very similar program when it operates. These requirements are in place, so we make sure we understand the condition of our assets. And so we take that seriously, of course, and monitor them effectively with the program as best we can. All right. That's it.
All right, thank you both. Before we move on to committee discussion, I'd like to invite the regulatory perspective, starting with ecology. Who would like to share that?
Thanks. So we have two staff to speak to the single shell tank side and the double shell tank. I think, Jamie, you want to start with the single shell?
Sure. I'm the single shell tank engineer that's mostly involved with retrievals and it's monitoring of those and those kinds of things. I think that over time, we're getting better at doing all kinds of things. DOE and the contractors have been making improvements, and like with the, we started a long time ago with the dome deflection study where we put 3 or 4 markers on the top of the tank, and the only ones that have exceeded their things were somebody bumped into the tank marker and it did that. But now that they have the 3D laser scans and stuff, I think that provides a really good orders of magnitude better evaluation of what the tank domes is looking. They've been very useful for the spalling that's been going on in the tanks and helping to do that. Before I came to college, I was at PNNL and I was in the same group with Ken Johnson, that group that did the structural analysis that was early on looking at the tanks. And based on that, I got to review some of those reports as the final before it went out the door. And I think what that shows us, and I think the follow-up has done as well, is that the factors of safety on the domes are pretty good. We're not going to fall down and do stuff. The spalling is a little concerned, but as long as we keep monitoring that, I think we're in pretty good shape. But we need to do that. And on the double shell tanks, I know a little bit of that. They're making improvements there as well. And I think they're doing good. One of the topics that was talked about really briefly was the interim stabilization that, quote, remove all the drainable liquids from the tanks. Well, the criteria for that was every tank had to be below 50,000 gallons of drainable liquids, or as much as they could pump out. And but when that was put into place, all the single shell tanks were supposed to be retrieved by 2019. We still have 3 million gallons of drainable liquids in the single shell tanks. 20 of them are above 50,000 gallons, and that's probably due to some intrusion, or we have much better monitoring data now to tell us to do that. And we're decades away from retrieving a bunch of these tanks. We have 2 declared leakers right now, so I think we should consider whether or not it's time to go in and maybe retrieve more of the liquids out of these tanks to help prevent that thing. We need to do a practicability evaluation of that, but I think it is one thing to look at. And part of the problem I see is that right now we have 1.1 million gallons of free space in the double shell tanks. So we can't keep retrieving tanks for very long until we actually get to the place where we're processing the waste. And now that the low activity waste is coming up pretty soon, I think maybe we can make good progress with that and we can continue to retrieve these tanks. But one of the concerns I have is we're not going to be processing any sludge wastes for a long time. I don't know how long that will be, but The, and the space in the double shell tanks is already limited. Fortunately, 17 of the double shell tanks have no drainable or no sludge placed into them. And one of the concepts I've been playing with is maybe we should stop retrieving sludge into those specific tanks, because if you put sludge into a double shell tank, it's just as hard to get out as it was getting out of a single shell tank. But it's going to be using up the space that we need to keep retrieving the other tanks as well. And another part is, like for AY102, one of the issues associated with it and why it started to leak was it's much harder to control the chemistry of the tank wall when you have sludge in the tank. So I think that's something that needs to be really evaluated. And I don't know if this is practical, but another concept is if they just have salt cake and liquids in them, you could retrieve those tanks completely. I don't know what completely means, but and be able to do inspections on the inside of the tanks and the tank bottom. I think it needs to be evaluated whether that's practical or not. But it would be a much better inspection techniques. They're doing good to try to improve inspecting tank bottoms through the slots, but that's a hard problem. So if we do that, another side benefit would be when we get up to closing these tanks, it'll be a lot easier to close them if we don't have sludge into them. Right now, the waste feed criteria for the WTP means we need to do considerable waste processing to get the particle size and other parameters down. And it's going to be a long time so those facilities are even designed or put into place. But from my perspective, it'd be much better to, when those are up and going, or we have new tanks that are designed that are easy to get the sludge waste out of, then start focusing more on retrieving the sludge waste so it can go to there, so it can go to WTP and doesn't have to take the longer path. Now, these are pretty much my concepts. I don't know if anybody at college agrees with those or not, but it's just to provide you guys some insight of how I think possibly we could be doing things better. I think DOE and the contractors continue to make good improvements, but you know, we're going to be here doing this for a long time, and I think maybe we should go back to the decisions we made a while back and go, or were those the best ones, specifically about did we retrieve enough dry liquids out of these tanks, the single shell tanks that are going to be retrieved for a long time, and some of those aspects. So, sorry for talking so long, but
No, thank you.
Appreciate it.
And for people on the phone, would you just restate your name?
James Alzheimer.
Okay, great.
And then, Ambika, do you want to go and just be mindful of time? We just a few minutes, Ambika, thanks.
And you'll need to you need to unmute.
This is Ambika Chakraborty. So Ecology Participates is the award of the Integrity Assessment Program. It is a very good program for the DSTs. Assessing on the ongoing integrity is an important issue for the protecting environment for the tank waste and having available tank space to support for the future waste treatment. One question I have, integrity assessment DST should be risk-based. So say for example, you know that AY101 is the highest risk because 10 years interval, it is a one size fits all because inspection should be on the rig space below the 10 years. I like to emphasize on this issue so that we can inspect all the high risk DSTs. You know, maybe 3, 4, 5 years. I don't know that. That has to be assessed. What is mostly discussed here is the NDT of the primary tank liner and the extent of the condition of the annulus. This on the ongoing assessment is required in the regulation and in the future permits too. We actively follow the techniques and advocate for the improved technologies where possible. Tank refurbishment is an interesting and important topic, but how to do that? How it is related to the ASME codes. There are a lot of technologies available, I understand, but how you are developing the technology. We like to know that one. Repair of the tank or, like that, how the technology is assessed, because it is already embedded. How you are testing, it will be strength properties are well regained. Another thing, beg your pardon?
No, all I was gonna say is that there's a couple of concepts embedded here, so maybe somebody can just recap at the end some of the key takeaways. Go ahead.
What modification or reinforcement are possible, how they would be done, it is effective or not, it is affordable or not, is a regulatory allowable from the ecology standpoint. That is a very important point. And the repair of the vessels. Now, I understand a lot of technologies are available in the market. So what is not discussed in the integrity assessment of the various transfer lines, which is also important set of activities that is needed for a healthy DST system. Some lines, SL lines, so cross-site transfer line was not discussed. We don't know the condition of those 3150 and 3160, as well as some lines, SL lines have a lot of last inspection shows lot of pitting corrosion depth 0.05 inches. Now, how long those lines will last? Nominal thickness of those lines, the 2-inch lines, about 154 per ASME B 31.3. But are you engaging any fracture mechanics approach to predict the life of the pipe? It is very vulnerable line, close to the allowable thickness right now. Some of the lines, SL lines. We have not get any direction on that. Oh, that's it, we have.
So I think the main question you had at the end was just, do we need fracture mechanics approach to determine the predicted life of the slurry lines?
So you touched on transplants directly, I think,
Yeah.
and that I think that's another area of the inspection program that we monitor. We have a number of transplants across the tank farm system. The active ones we use are in the DST system. We have about 79 transfer lines total that are active and are used for moving waste around within the DST farms, between the DST farms, to the evaporator facility, and then eventually they'll be used also to move waste over to the waste treatment plant facility. One thing he touched on is we've been doing an investigation the last year and investigating, I think, that happens perfectly aware of it at least, monitoring various areas of that transplant system and conducting inspections to measure wall thickness of the transfer lines, conduct some higher stack testing of the transfer lines. The purpose of this testing is to characterize the condition of the transplant system to support the DFLAW mission and the mission in general at large. What I would say, I guess, Ambika, is yes, we are utilizing as the FFS1 guidance to evaluate different load scenarios for the transfer line system. And we're using the data we gather to compare to those various required thicknesses from the transfer line system to support the different demands they have, whether it's design pressure or thermal loading or seismic loading, or whether it's, and given different scenarios, right? So there are various failure modes that a transfer line can experience. It can be localized panel degradation, where you get a leak integrity failure, or it can be uniform wall corrosion loss across the transfer line length, which would result in a structural failure, which is much more impactful, as you can probably imagine.
Yeah, but I like to know the crack opening displacement, because you have a lot of corrosion peaks, some are very high, So how to detect all those? What is the life of the pipe?
Okay, yeah, we can follow up with it and probably provide a briefing to you guys at the college if you wish on the results. We have an action to do that, Ambika. We're finishing up the investigation right now, and I know we've talked in a prior briefing we gave you guys on this topic. We can meet with you after that investigation is concluded and the results are all finished, and we'll share the results of that with you.
What about the inspection frequency of the DSTs? It should be risk-based or one size fits all, 10 years. The 102 is a high risk, as per your report, ASMT 61284.
Right.
Some other tanks are very high risk too. Do you think expedited inspection frequency or 10 years?
Right, so the integrity program for the inspections of the DSTs right now is not on a risk-based strategy. We do increase the inspection frequency when we have observations as part of the program to monitor them more closely. And that has looked like more frequent inspection of the liquid air interface of some DSTs where we found any evidence of localized pitting in that region. It's included more frequent inspection of tank secondary liners in areas where there's been evidence of corrosion on those secondary liner bottoms. And that looks like every 2 years or every 5 years in those cases, where our normal program would say 8 or 10. What we are, I think, considering doing, and we haven't done yet, is changing to a risk-based strategy for inspection for UT of the tank walls. Right now, we do them all on the same frequencies, barring any sort of one-off cases we find as part of that inspection program. But if we do need to evaluate tanks like A111, like you mentioned, or others that are older, we could consider doing that as part of the program.
Okay.
All right, sounds like the rest of that will be called up in a future meeting.
Yeah.
Yep. So I don't see anyone online from EPA project perspective, but everyone's invited to speak up if I missed anyone. That seems to be the case. All right, I think we're free to move on to committee discussion. Who would like to start?
I've been paying attention to the program since Cal Bluter's here. So, lots of questions. The inspections where we were understanding that we would get a lot of relief, especially on the double slit tanks, was the phased array approach. And it was not mentioned here in your presentation. Has it been determined to not be effective, or too much effort, or too confusing?
I guess the term we'd probably say is that the juice is probably not worth the squeeze, is what you'd say.
Okay, got it.
So we did procure the technology, we had P&L test it to a significant degree. It's not a large improvement what we currently do, enough to warrant using that technology. What we've done instead is we'd rather look more places with the same tool than look at one place much better, if that makes sense. And so the tools we have now are effective. They do find the degradation we're looking for. That's the key point. These tools also find the degradation, but they are at a significantly higher cost. And they don't provide us more coverage like we would have hoped for. The other technologies we looked at that are similar in terms of trying to look at the walls better are EMAT, or electromagnetic acoustic transducers. The promise there was that we could look at more area to a lesser degree of fidelity and try and characterize and then go look more closely at the areas. That also proved to be marginally effective. And so we didn't pursue doing that as part of the integrity program either, but we have evaluated those things. The tough part about technology maturation, I think, and technology development is people always expect it to work. When you start the process, like, oh, if we just do the work and put the money in, it's gonna be great, and we're all gonna have a better tool at the end. Sometimes we have to try it to first know that it's not gonna be effective. And that's really what the case was with EMAT, I would say. And we've tried other things, like if you're familiar with thermal imaging at all, we tried thermography for DST sidewall inspections. Because we were looking at that point in time for faster inspection of the sidewalls to, again, give us relief to spend less time on that and spend more time on the tank bottoms or where the challenges we found were. So again, that also was not effective. The tools couldn't be reliably, sized down to fit. We didn't have long enough tether link capability given the voltage requirements. Lots of reasons for those things being impractical to use in our scenario. So we leveraged back to the tried and true method of just localized UT with the tools we use and the transducer we have. That also allows us to compare to our prior data effectively too, because it's been the same technology for those several decades, and it gives us that ability to detect. And it wouldn't be a significant time savings either to do this, right? It's not faster.
Well, one thing that was brought up in that technology development was typically on stainless steels, which are single phase materials, it works a lot better than carbon steel, which is a two phase material.
Yeah.
Okay, so I had a couple more questions, but can we go around the room first? And
I see.
I have one question, but you didn't disclose anything about cross-site transfer lines, for the integrity program, how it will be done, or what is the time frame?
So Ambika, I think for this presentation, we're primarily focused and requested for tank integrity itself. I think if the HAB is looking for a follow-up on pipeline integrity.
Okay, yeah, well, we'll come back and probably do an infrastructure integrity. Because that is a 7-mile long pipe. It's been in the ground for years.
Yeah, this is brief summary to answer that more. There are about 10 miles of pipe on the transfer lines in the DST system in total. 7 miles not just the cross site lines, but there's also internetwork of transfer lines between tanks as well, as I mentioned. So that's another area we expect to monitor. We're happy to chat about that too in the future if you guys want.
Sounds good.
So the queue, as I saw it, was Larry, Matt, and Mia.
So you've had one failure of a DST, and you didn't mention failures of single shell tanks, either that or I had a senior moment and didn't get it. So I'd like you to spend just a minute or two describing what the mode of failure is and kind of where the failure is and whether you have the ability to heavy up on obvious areas that'll fail, or if the fails are a little bit arbitrary. Can you address that?
Yeah, so there's a document we publish every month, I guess. It's the Waste Tank Summary Report. That's a public document that anybody can review and see. Goes to ecology certainly, and they're involved. When a single shell tank is determined to be leaking, we use a process called the leak assessment process, which is a regimented, regulatory, procedure-driven process. We evaluate all of the data we have about the single tanks, which is in-tank monitoring equipment, like Eric mentioned. We have measuring equipment for the level of the tank, whether it's the surface level of liquid in the tank with an NRAD, or whether it's measuring what we call interstitial liquid level, which is the liquid that's saturated with the solids tank. As Eric mentioned, most of the pumpable liquid has been removed from the SST fleet. And then Jim, of course, mentioned that there's some water that's in there due to intrusion or otherwise that's residual still from history. So there's ability to monitor what that liquid content is and look at it over time with both monitoring technologies, which we do in accordance with our 9937, RP 9937 primary document, it's a TPA document. We do visual inspection to confirm and look for any evidence of changes to those intake conditions. So if we see evidence of a liquid pool forming, we might know there's intrusion. We might go and look into that further. If we see evidence of a liquid pool depleting, that might be evidence of a leak, right? Those kind of things are part of the things the program looks for. And then beyond that, the RPP 9937 document provides the framework for which DOE and ecology work together to evaluate those different scenarios in the event of an SST leak. So if an SST is found leaking, up to now, that document said DOE and ecology will meet to figure out what to do about it, essentially, right? There's a number of SSTs that are assumed leakers. There's a list that's published on a monthly basis, like I said. That
Should that document be more specific in future?
So when it's coming to leak response at the time, we're working through the agreed order at the time. That's, I think, that will be an evolution and what that response looks like.
Yeah. Kind of where I was.
Sure. Yeah, we're still working with the state on it, working through that process. So maybe, I don't know if I can speak to quite where we're at with it right at this time.
I mean, from our perspective, it'd be best if you had a checklist, right? And that's not gonna happen, but.
What do you mean by checklist?
Well, when you observe liquid change or a thin wall or something of that sort, you just automatically go to do that. That's not gonna happen because it's not a linear process, but anything that could be done, I think, to be more specific about addressing that.
About the response, yeah. Yep. I agree, you mentioned the agreed.
Yeah, I think a little bit I want to add is, I think in the agreed order on leaking tanks, there is an evaluation of new leak detecting technologies. And I think that's a good thing because with B109, there's so much scatter with the process we're using right now to monitor the liquid observation.
I understand that the tanks there's a lot of difference among tanks, and that the response is probably going to have to be different depending upon the tank and the contents. What did you learn from the failure of the DST?
Double shell tank AY102 was discovered to fail through really largely visual inspection in the annulus phase. So we ended up seeing was a slow weeping leak from the tank bottom of that tank. which resulted in liquid being present in the annulus. If you're not familiar, the annulus space is ventilated actively, so that liquid dries out very readily, and so you end up with a scabbed solid salt cake on the bottom of the annulus floor. So we saw that and watched that develop via visual inspection for many years as we prepared material or technologies and tools to retrieve that tank. When we retrieved the tank, we of course removed all the liquid head of the tank to begin with, and then we were left with the solids. As was mentioned previously, solids are as hard to retrieve in a DST as they are in SST. And that's really one of the challenges we're gonna face as we
So
go
was that
forward.
a failure on a seam or was it corrosion?
No, yeah, I'll get there. So,
Okay.
so I'm trying to paint the picture for you here. So we did the visual inspection, of course, in the annulus space for quite some time and monitored the condition of the leak. And then we started doing retrievals of the tank and moved the waste over to other DSTs. We got to the solids, retrieved the solids. Once the solids got low enough, we started to remove the scabs in the tank bottom and it started to leak more aggressively into the annulus space. The liquid we were putting in there for sluicing and pumping out started to simultaneously flow into the annulus. Of course, in the annulus, we had a pumping system to move back into the primary tank. So we're constantly shuffling the waste around, right? Keeping the annulus below a certain level during this process. And then eventually the tank bottom primary gets low enough that that's over, the tank's empty, right? And all you're left with is some residual solids on the bottom. When that was the case, we put cameras in, high quality resolution, high resolution cameras that we purchased and better lighting to look at the tank bottom and survey what was going on, what corrosion occurred. We were curious to know that because we want to know if it's a latent problem for that one tank or if it's a problem for all tanks, right? And that's largely why we're doing our other inspections for tank bombs now. What we did find for A102 was localized pitting corrosion of the base metal, not necessarily welds or seams. And so you end up with a further analysis we did to look at what corrosion chemistry did this tank have over the course of its life. We do, if you're not familiar, he showed a picture on his slides of a core sampler. A core sampler is basically, think like a soil sampler in the ground. You're cutting a core through the surface and you're taking those cores out and analyzing what the constituents are of those different cores. We do that in the tank waste. We do it for the various layers of solids. At the very bottom of the tank, when you're in contact with the tank bottom, it's very difficult to get that material and get into a core and pull it out and go analyze it. So what we did as a result of AY102 was modify the core sampling platform to have a technology called syringing. So when we get the core sampling nozzle to the bottom of the tank, just close to it, we're able to suck in that fluid, the interstitial liquid that's present there in those solids, and then take that material to the lab environment where we can do corrosion testing. We do a series of corrosion tests. One is called cyclic potentiodynamic polarization, which tests for the proclivity for pitting of a solution in a certain environment on a certain steel. We do electroresistivity, lots of different tests to characterize the degradation that material might cause to the tank you're containing it in, right? So we did that and found that at one point in time in the life of the AY101, there was some high chloride waste that had been added to that tank, which resulted in some localized conditions in the tank bottom that were unfavorable. And then over time, as was discussed, it's very difficult to modify those conditions. You can't go and really heavily mix solids in a DST that's 7 foot in diameter and inhibit those corrosion conditions at the bottom. And so it's very important that we add inhibited solution to those tanks and monitor and make sure it stays in that condition over time. And so that's what we found. And then beyond that, we've improved the program. Of course, core sampling, we do syringing every time now. We are working to inspect the tank pumps more readily. You mentioned when you empty tanks to look at the bottom of the tank. That's a fantastic strategy. It is built in as part of the program. We say that if we're pumping a DST down to an empty state, we want to take that opportunity to go put a camera inside there and look around and see what's going on. When we did that for AP106, folks are probably familiar with AP106. It's like the poster child for TSCR right now. It's the feed tank for the DFLAW mission. Well, when that was being repurposed several years ago, we had it pumped down to like 10 inches left in the tank. And so we put cameras in there to look around. Because you can see through the liquid and see the tank bottom and see the weld seams and the like, right? We wanted to know what was going on in that situation and understand if we had any issues with the tank we could be concerned about. So we have that data and we utilize that to great effect. So those things don't happen that often. We don't often empty DSTs. That's not a daily occurrence. It's really a one-off operational thing we had to work on. And a lot of them have solids in them, and some are group A tanks that we can't really manipulate because they have gas challenges. So there are limitations for sure as part of those inspections. But does that
well, that was the purpose of the question, is to whether you guys learned something. It sounds like you've got volumes of data on tank integrities.
Absolutely.
Thank you.
Can I address this particular issue. We have a presentation given to us of the 102. And you've seen it with the red marks. And there seemed to be 7 places in there, and some were associated with well stress. And the stress engineers, because we could not identify it, it was still unknown. So now you're telling me it's pitting. So what was newly learned to say that it was not a stress-associated crack that penetrated the bottom of the vessel?
Really, the visual inspection didn't show any evidence of degradation at weld seams or in the defective zone around the weld seams. We didn't see cracking as part of those visual inspections. We saw localized pitting corrosion attack that was in the base plate away from weld seams, more indicative of exposure to a harmful uninhibited solution. So that's what we then investigated and discovered through the history of the tank's chemistry, kind of walked back the history and saw what we had when and where, modeled it with a software tool we used, and we're able to understand really over time through a forensic analysis what we think happened. And that was a unique case for ABLE 102, which is in some ways a comforting thing to understand.
Yeah, that's probably for the rest of us, it's probably much easier to use cold spray to prepare for a pitting than it is a crack.
Sure.
Because the crack is through wall, extensive. So, you know, your repair methods are, yeah.
Sure, those are all things we have to test as part of the development of technology. So you can, whether you can repair through all penetration or not, so.
Right, thank you.
Yeah.
And being mindful of time, we'd like to make sure we get through the questions, so maybe try and strike the right balance of detail, but Matt, I think we're to you.
I got a couple for you, and I'll try to be quick.
Sure.
Help my assumption here, and I hate to beat the dead horse with cross-site transfer. Comes out of one tank, goes to one tank only. There's no transferring that line. It comes west to east side, one tank only. When developing a risk-based inspection system, I would like to, this is me personally, it might be advice that this group might formulate, is what you prioritize, what gets a higher rating. And those 2 tanks, to my mind, are one of them. Correct me if I'm wrong with any of those assumptions.
That's correct. The tanks, the line goes from one tank to another.
I'm going fast, I'm sorry, I had to breathe. Talking about AY 102 and the good work you did there with testing, especially your new equipment. Has that knowledge gained, and have you tested some of your newer integrity equipment on that tank? And how is that, you talked a little bit to it with Larry. That has informed, say, a baseline for your other ultrasonic testing, anything like that? How is that, a real brief synopsis of that? And then I've got a quick one on the cold spray.
Sure, let me address those 2 real quick.
Okay.
So the first, you talked about the cross-site transfer line, risk of certain tanks and their operational needs being impacted and need to be inspected more often. That is an element of risk, right? So risk is the probability of occurrence and consequence, right? Consequence is higher if the tank we need is much more important to the mission, right? Because if it's a tank in AW farm or AN farm, I can tell you right now, if it's not related to transferring, all we gotta do is you got a tank. We don't need to put stuff in there and do any kind of mixing or anything else, right? AP farm, much more challenging. AP farm tanks right now are highly slated for the DFL mission, future DHW mission, and the like, right? Those are going to be needed for a longer time. They're also the newest TSTs, which is advantageous. Whereas, so to your point, yes, those are factors that have to be included as part of an assessment of which tanks and which lines and which structures you inspect and at what frequency, so you can ensure that they have a long life. We do sample and make sure all the tanks are healthy, that they're inside their chemistry and they have perfect chemistry. We don't want any tank degrading, obviously, so we need to make sure they all last for as long as possible. But we couldn't change our inspection program in the future to monitor, from an operational perspective, tanks that are more have higher consequence. And then to your point on A102, yeah, I would say A102, we gained a lot of information about the condition of the DSTL and tank bottom due to what we think occurred to cause it to fail and degrade. That influenced our inspection programs as well. We look more often in the annuals and DSTs now than we ever did. We used to do 5 and 7 year inspections, depending on the tank, and now we do all of them every 3 years with better cameras, and we do more coverage as well. We only looked in 4 risers before, which is a pipe from grade down into the annulus space, so you got less coverage of the perimeter of the tank. If you look in enough risers now, which is usually 10 to 12 risers, to get coverage of almost the entire floor of the ambulance. So if there were a leak from the primary communication, we would see it via those inspections with high probability. We are developing the tools to go in the ambulance space, under the tank, in the primary tank, under the primary tank, in the air cells and the refractory pad. The purpose of that was directly in response to A112, to go and understand the tank bottom conditions. What we found really is under deposit solids conditions in the highest heat regions of the tank are where the challenges are, and where we need to go and look further and investigate further and characterize better. So that's where those technology developments have come from, and that's why they're progressing along and will be utilized.
I'll hold the last one.
I think we have till 10:30, don't we?
Yeah, I was gonna quick recap of the queue. So now one more question, Mia, and I haven't seen anyone else in the room. Who you'd like to enter? Okay, so Steve, Jacob, and Rob.
I'll hold off on cold spray.
Just I see.
Mia, Jacob, Rob, Steve.
I'm glad you brought up AP 106 because it's now kind of being blamed for the excess levels of cesium in the treated waste. I'm wondering if there's inspection tools that you have today that would have helped in when that tank was cleaned out in cleaning it so that we wouldn't be running into this problem now.
Yeah, that's a good question. So AP 106, just a very brief summary, is the feed tank for the DFLAW mission to WTP. What we're doing out at the site is taking waste from AP 107, which is a neighboring tank, through TSCR. The product of the TSCR system goes to AP 106 and collects. The TSCR is meant to get that tank waste treated to a point where it meets the spec for WTP, which is a certain amount of cesium, a ratio of cesium and sodium, and the like. There's a spec that exists. It's a very challenging spec, so we're all aware. Very low concentrations of cesium. What happened in AP 106 is back in 2018, we repurposed that tank. We pumped the waste down in that tank. We added dilute material and caustic to really get all the cesium we can get out of that tank out of there by pumping directly. And then we moved that waste to other places. And then we started to fill AP 106 with the treated district product, which is meant to be low in cesium. When we did the repurposing for AP 106, we did in-tank visual inspections as part of that. As I mentioned, looking at the bottom, we also looked at the walls though too, and the walls have residual salts on them that were, crystallized there through the course of operation. That tank's been in service for 40 years or so, right? And so it had residual material on the walls. And when we went in to fill the tank from AP 106, what we think occurred is that now we saw cesium leaching from that salt on the walls into the product from the TSCR. So we needed to allow that to happen, of course, now through filling it up higher, allow that cesium to all leach into the low cesium supernatant that's in there. We have to now reprocess it back through TSCR to remove that cesium that was added into the product in the tank. So that's where we stand with the TSCR and the DFLAW mission in AP 106. We have tools though to better understand that condition. Only better cameras. We don't have any way to visually or put a tool in the headspace of a tank like a DST and analyze what's on the wall. You can see that there's salt there, and you can make a risk-based choice at that point if you wanted to. There's always been an identified risk that there's latent cesium in areas in the tank that could leach into this product. You don't get around that unless you go to some new tank, or if you spray the walls, get all the salt off, dilute that, add a lot of material to the system as a result. There's downsides to doing that process, and we didn't do that previously. That's where we stand now. So the result is you have to reprocess that waste and get it down below the acceptance criteria for WTP, which is what we're going to do.
Yeah, thank you. Sure. Josh, can you help me to the end of the queue?
I will add to the end of the queue. All right, Jacob?
Well, I got a couple of things. One, might sound like I'm picking on you, and others, might sound like I'm picking on ecology, and so don't want to be on both sides, I guess. But first starting with A102, I think a lot of people forget the actual very first clue that there was a leak was a rad monitor on the annulus ventilation system. Multiple years before it leaked, I had people telling me everybody knows that tank is leaked. But because of that rad monitor. And so that gets me to something that ecology said a few months ago when we were talking about the Rev 9 permit. They said that we haven't seen the new Rev 9 permit, none of us have, but ecology did tell us that one of the things they were going to put in it is additional inspections for tanks. And one of the things I'm concerned when I hear you talk about technologies, that they were great, but their added value was pretty small. I would just want to make sure that we don't get those as a permit requirement and all of our money goes to inspecting tanks. You know, that isn't an added value. And so my question is there like some resource we could go to that could sort of see, you know, here's what we learned about the effectiveness of technologies and which one are a toy for studying AY102 versus a routine, you know, tool that you can use to get routine sort of information. You know, and of course, we don't know what ecology is going to actually have in the permit. I'm just trying to be prepared for that, you know, potential situation, those potential comments.
Sure.
Or permit conditions.
I think just in my perspective of our interactions with ecology on the permit, and ecology can certainly speak to this as well. We've largely leveraged our integrity program document and what's in there for our inspection program requirements, and what we have settled on is what's effective for the program to monitor it. And as we change that program document, this is why through the discussions, we wanted to make sure the program document was within our control to modify, because if we need to add new technology or look at a different frequency, less and a higher frequency in some cases even, we want to be able to do that and adjust and be flexible with the program and not have to go do a primary document TPA revision to do those things necessarily, right? So I'm curious, ecology's perspective on
I
that.
was just gonna add we'll come to the HAB when we have more set permit dates, and we'll give a briefing to the HAB and we'll be able to answer those kind of questions. So, yeah, there'll be a venue to ask those questions and we can answer them more in depth when we have all the right permitting staff on hand for that.
Yeah, it's just for the size of that document, there's not a lot of time to. Yeah, and so that's. And do I have time for one more?
Sure, go ahead.
You know, so the other one is high-level waste mission. You know, the integrity for a stirred tank is different than the integrity for a stagnant tank. And if you thought through how you're going to monitor, or if you need to monitor, or just inspecting the tanks now to make sure that you're planning to use tanks that can be stirred.
Yeah, I think, we're still, the high level waste missions, and still, there's a lot of decisions that have to be made along the way before I think we'll have an idea of how to probably address your question there. If it's something that we'll have to follow up on, definitely.
Okay.
All right, now that we have about 5 minutes and 5 people in the queue.
I want to just check a few things, so we're gonna pause here. There's a break. If there's interest in reducing the break, but we've got 5 minutes and it is Steve, Chris, revisit to Matt and Mia. So do you want to be added back in the queue?
Oh, yeah, I just had one question.
Okay, well, we'll put you back in, so Steve.
I just quickly, risk assessment related to the single shell tank leakers. Do we have a level of effort list that lets the public, lets you know what you're actually focused on in terms of effort? And when I say that, I'm just thinking you've got some single shells that are emptied and taken care of, and so these are low level risks and low level efforts, and then you've got, I would imagine, an effort list for the ones that you're really trying to pay attention to, no leakers or things that haven't been explored. I was just wondering if you could just touch on that.
Yeah, sure. So I'll say the key place we go to characterize the integrity status for tanks is the waste tank center report. That's where it's documented for any tank, whether it's sound or assumed leaker. That is the place where we characterize that status, at least. Beyond that, I would say the negotiations of what to respond to in terms of the SST fleet for retrievals is really where you go to for where the risks are. The retrieval process and the planning for what to do for next retrievals of SSTs, whether they're leaking or not, is largely based on a lot of factors, including the consequence of failure. What's in those tanks is a key factor, right? What chemical constituents are in those tanks? What's the hazard of those tanks? And that's one of the factors that's included as part of the possibly the leak response matrix. What do you do in any given scenario? What's in the tank? What's the access to the tank? What's the hazard caused by that particular tank leaking, given what's in it? What's the means by which you could impact that condition through any response to action and the like, right? Those are all things that are factors in how we choose to respond in any given scenario, and that's always gonna be a response. It's not just dictated by DOE, but it's a DOE and ecology collaboration to make that decision. We both have to be on board with that strategy from a perspective of how to respond to SST leaks in those cases. The goal, of course, is to treat all the waste and ultimately, but how do you prioritize that? I think you prioritize it, just my own personal perspective, based on what the hazards are and what the consequences are, and try and limit those impacts as much as you can. Keep in mind, you also have other contractors, some like CPC go there doing groundwater remediation in areas too, to prevent the hazard bubble leak of a particular social tank in certain areas. So that does help a lot too.
We have an agenda update, so I want to check with our presenters and agencies. We would like to propose, the chair discusses with us, and we'd like to propose that committee business be pared down. It would give us an extra 15 minutes. We would break at 10:45, reconvene at 11 for committee business. Is that acceptable? All right, so that gives us a little more flexibility.
All right. Okay, so with the magic time, quick recap of Q, we got Chris, then revisiting Matt, Mia, and Rob. Chris.
You mentioned that for the tank 106, you were unable to know how radioactive that scale was on the wall. There is a tool called a gamma ray camera that was especially developed to take pictures of insides of tanks, of walls, and the picture then would show where hotspots are of gamma emitting radionuclides. Have you investigated anything like that? Because I think you can make it small enough to get inside some of those tanks and take pictures to see where the intensity is of gamma emitting radionuclides.
We have not investigated that, I guess, directly. I was not familiar with it personally, so thanks for sharing that. We'll do some research and look into it. One thing we have done and we have been doing as part of the process here of filling up a B106 with treated TSCR feed is sampling it periodically. So the idea there is if you sample it and then you sample it sometime later and you see no uptake in cesium in the sampling, that is an indication that you're not receiving more leaching from the sidewalls. And so at least in the recent several samples we've done since we got to our final batches of the last campaign of TSCR operation, we have not seen an uptake in cesium beyond what it had previously in the waste as we approached the solids on the wall and covered them up and then had them stagnant there for a period of time. So the suggestion there based on the data is that we're not seeing more leaching of the wall material, and that's already leached into the material as it was there previously. So that's a valuable finding, and that's how we're characterizing it as best we can, is just by doing sampling, taking those samples over to our lab, analyzing them for cesium presence. We are also recirculating the tank waste aggressively. So the purpose there is to make sure it's mixed. If you're only getting localized leaching at the walls, it doesn't matter if you take a sample in the middle and then characterize it as having nothing, because they could be over here at the wall, it could be much more, right? So before we do the samples, we recirculate for several days so the waste is homogeneous, and then we can take a sample and understand that we have appropriate characterization of the supernatant that's present in there. So that's how we've been convincing ourselves now that we have an appropriate position now with regard to leaching cesium from the walls, so we can go forward and reprocess it, and we'll be in a better state than we have been to then feed WTP with that waste.
Yeah, the gamma ray camera, if I remember correctly, was developed by BNFL. And going back more years than I want to admit,
sure.
I kind of think that Canberra may have paid for the patent, and they may have something similar that you could purchase. I don't know, but it might be worth looking into.
Sure. Okay.
If you could take something like that and take gamma spectrometry pictures of hotspots or near hotspots on walls, it'd probably be less expensive than physically taking a sample, sending it to a lab, because you could get a broad picture and maybe avoid excessive sampling.
Sure. One thing we have done that is sort of in a similar vein to characterize the material on the walls is look at the process history and sampling of the tank itself, understand through our own understanding of the salts that precipitate out and what those would contain and how much percent cesium those would have in them. Cesium is very soluble if you're not familiar. It will be in the liquid phase most likely if there is liquid present. It'll be soluble in liquid. And so that was one of the factors for which we thought maybe there's not a big deal that it's solids in the wall because there's not a lot of cesium in solids. But it's cesium in the liquid contained in the solids that is the challenge on those wall materials, right? So as those dry out and slough off, or as they are covered by supernatant, they will be absorbed and brought into the supernatant itself because they are so soluble. I'd be curious about the gamma camera and whether that camera can detect just the presence of cesium and to what degree, because what we're trying to get to at this point is how much cesium, not just that there is or isn't, right? So that's the real challenge. What degree, how many curies really are present on the walls, right?
Yeah, and I can't answer that. It's been a while.
Yeah. That's the challenge. That's where we're using the sampling results to give us that. Is we have to get below a number of how many cesium there are in the tank.
Be like taking a picture of the sun.
Yeah, right. Yeah, it's bright, all right.
And that.
All right, this might be a little early, but cold spray.
Yeah.
Is there a minimum thickness at which that would be contraindicated? That you know of? So
Contraindicated, please explain that.
So if your tank wall is only half an inch, right, or let's say a quarter of an inch, you don't want to spray it because there might be enough a blade of
force
to penetrate.
We've used the technology in various scenarios in a testing phase at least, where it shows you could build up thickness from the outside substrate inward over time slowly, and you would be able to close the open hole. Not necessarily, you wouldn't want to do that, I don't think personally, if there was liquid on the other side. So the way you get around that, knowing that you could do that, you could spray a thin wall and build it up and it would be fine, even if it did penetrate through temporarily, because you know you're gonna build it up. You'd want to empty the waste down to a lower level on the inside surface so you don't have a leak when you're doing the application, right? So that's things you have to think about in terms of the actual physical deployment of the tool. It's true that it could blade through, but it will also build up the material at the same time as you continue to use the tool. So you want to make sure you're not causing a leak while doing it though.
Second part of that, I understand the reason to use the same alloy, this carbon steel. Has there been any research into different types of alloys and how that would affect things?
Yeah, we've looked at whether you can apply stainless steel to the carbon steel structure. The reason you care about the alloy you use is largely due to galvanic corrosion. You want to have a galvanic cell that's not too dissimilar in terms of electronegativity, so you don't result in a corrosion of your anodic material. In the case of a carbon steel structure, you would like your patch to be more cathodic and have the tank be the anode, so that it's a larger material structure, and then the small patch is the cathodic piece, which doesn't degrade. So those are things we're thinking about, and certainly testing multiple materials, various types of carbon steel. You'd be surprised, carbon steel is not very common for cold spraying. In its small form, it tends to, oxidize. That's a challenge. And so you use alloys of it, and we've tried stainless steel as well. That has effect also. Part of the regime for testing of cold spray is not just material integrity, but it's also corrosion chemistry and material compatibility. If we put this material on our tank and then we put our exposure of our waste to that material combination, and that corrosion cell that exists then there, is it harmful? Will the patch material corrode away readily? Will there be crevice corrosion behind it? Will there be localized pitting attack? Those kind of things are things we're doing with our expert panel we have on tank integrity. Part of that is corrosion chemistry, and then we have a lot of labs that support us for doing that work to judge it. So again, we're not going to use the tool lightly and with the expectation it's going to work when we haven't tested it in advance. That's the key thing.
Is that it, Matt?
That's it.
Okay.
And that's remaining, Mia.
I'm wondering if you can share, you were here last time in October of 2022, so that's about a year and a few months. Are there any developments or updates that you can provide that the committee should be aware of? I don't track your program as closely as Rob does, and so I'm just curious if there's anything you could share between October 2022 and now.
Sure.
I think
I can share, I think one of the highlights of the program was we completed our 149th baseline visual inspection for our double shell tanks, or single shell tanks, excuse me. So that was a big milestone for us. There's both literally and figuratively, there was a TPA milestone report as well that we completed on time. The
That's a huge bonus to our program to be able to now have reference images for all our single shell tanks. And now when we're going to progress, we're not going to stop after just taking the baseline images. We're going to be coming back to these things like what Jason said frequently, and be able to compare the conditions that we observed through our baseline inspections to what was done, in the future. And that was a big evolution. I mean, it took over, I think 15 years in total, with a lot of data analysis that went into that. So I think that was at least one of the first accomplishments that comes to mind for me. I don't know if you've got anything else you want to add.
Yeah, I think my perspective is I've been involved in the program for about 12 years, and I've seen the evolution of the program from discovery of tank I-102 being failed, the first DST that observed failed, and the paradigm shift that caused with our inspection protocol for DSTs, better visual inspections, more visual inspections, increased areas of NDE. So we've been looking in the secondary liner bottom on every DST since 2014, which has brought us a large body of knowledge of what's going on in that environment and repeated inspections in that area. We have, of course, been monitoring all the SSTs like Eric mentioned. We have those baselines, but I think one of the hallmark new features, as Jim mentioned, is the laser scanning capability. The tools for that have become ubiquitous and available, such that they're scanning homes for real estate agents now, right? So we're happy to buy those tools and get them in a state where we can deploy them inside single shell tanks or in double shell tank ambulances, and give us some, authorized capability to do volumetric inspection at range when we can't put a robotic tool. We can't always drive to the location we want to inspect. So having a tool we can put in there and just like point a laser at it and do surface profilometry helps a lot in making decisions. It's helped a lot. Folks mentioned concrete spalling. Jim mentioned concrete spalling and SSTs and the impact of that on structural integrity. We were able to take those laser scanning tools inside of some of those tanks in SX farm, do an interior laser scan like Eric showed in the pictures, and show the entire measurement of the interior space. It helps you with the dome for one thing. I understand my dome is appropriately curved and it's not deflecting and it's not flattening over time. That's a great thing to understand. But we used it to actually measure the depth of the spalling in those cases and see how much concrete material was lost from the areas where it was dropped off. And then we were able to take that knowledge that we gathered volumetrically and measured and give to P&L. P&L retains ANSYS models, so structural analysis models for all the different types of SSTs and DSTs. So when we come to them and say, hey, we have this particular phenomenon happening in this area, and it's this depth, and it's this location, they can quickly add that to the model and then expand it even further beyond that in the model, and then determine what the demand capacity ratio impacts are for those tanks and understand if there is a challenge to the structural integrity or not. And like Jim alluded to, really, the tanks are very robust, and the degradation we've experienced at this point is not impactful to their structural integrity, but we need to keep monitoring to ensure it doesn't get to the point where it is. So that's why we do the increased frequency monitoring for those tanks, look at them more often with both visual and volumetric means, and make sure we are on top of what's going on. And then seek to mitigate it as well, which is another factor we have to get into as well.
Thank you.
Sure.
Okay.
And then Chris.
Okay, sorry. So last meeting, we were given a presentation, and I believe her name is Kelly, on the barriers that are being applied over the single shell tanks.
Sure.
She showed several slides of trucks driving over the tanks, dumping gravel, preparing the base, compacting it, then the asphalt goes on, and they have to compact that. My question would be is, have you done, because we know now that we're spalling from the dome and the laser scans and visual inspections. We were treated to some pictures by Karthik, I believe it was, that showed corrosion of the rebar that is now exposed from the spalling. And the question is have you gone back, or are you scheduling to go back and look at those domes after the heavy equipment had rolled over the top? Because we do know the double shell tanks are deeper and have more protection than the single shell tanks.
Sure.
And that's always been a question. And so the question there is, one of several, but I think that's an important thing to take a look at.
Sure. Yeah, so we will, of course, go back and do visual inspection inside of the SSTs, and we do those frequency as it's defined now. The question really is there an impact of doing a interim surface barrier in a SST farm? What is the impact of doing that? And so during the process of doing it. We manage the loads that are on the tanks, and actually through all operations in the tank farms, we do manage the loading above the tank domes in those tanks. There are seclusion zones in the tank farm where you can't put a crane, for example, and the like, right? Because of the amount of static load that we have and any transient loads that we monitor as well as part of that. So that's one factor. The tanks have a defined loading capability. We manage the loads so that we're below that by a certain threshold. If there's degradation though, that's occurred, and then that may reduce the structural capacity then, so you need to understand that. To your point there, as part of our program, when we did the visual inspections, for example, in SX Farm, before we understood their condition and their demand capacity capabilities, we have methods to institute operational restrictions. So we say you can't go above a certain percent of dome load in this farm in these areas until we can conduct the work to validate that it's okay. So that was done in the case of SX Farm. We have that process across the board for all SSTs and DST dome loading. I would say the characterization work we did with P&L supports the current loading of those tank domes. And then ongoing, we do those benchmark assessments like Eric mentioned to do dome deflection measurements for the SSTs. And those are still available to us, even if the farm has an interim surface barrier. They're attached to things like risers that are welded to the tank dome. So they're above grade and easy to measure with a surveilling equipment. So we still do those on the same frequency we ever did for all the SSTs and the DSTs as a result. So yeah, I would say there's a lot of aspects to the program, just to summarize, that affect the structural condition of the dome. Visual inspection is a really key one, but the dome deflection and the dome loading program are two key factors too that we exercise on a routine basis to make sure we're not putting a dome in a harm's way. It's not clear in SX Farm what the cause of the spalling is, because we have 149 SSTs, only a few in SX Farm have this phenomenon. If it was a loading concern, we do the same activities across all the farms. So that would be, or it should be more ubiquitous if that's the case, right?
Okay, so then a couple more questions on that. One is that you mentioned the identification of pitting corrosion in the bottom of Lung 2. That caused me more concern than the crack on the well. When it was on the well, I know it's localized, and then we have seen it, and it's probably not systemic. What I see now, if it is pitting, is that now this is basically caused by the chemistry modification on the sludge at the base of the metal. It deoxygenates, it acidifies. And so it's very likely you have many more random cases of pitting corrosion than if it is a line-on crack. So I just kind of keep that in mind.
So we're coming up on time because we do have the a draft advice. So is this your final?
Yeah,
item?
this is
Okay,
basically the big picture is that we think, first of all, we're asking these vessels to last another 50 years. They're already beyond their design life. The question is how are the expert panels determining remaining life on those tanks? Because right now they have kind of given a positive indication that we could go another 50 years on some of these tanks. So is the expert panel involved in the life analysis? And how, and granted, it's probably not known, but they're still working on it. But the question is that we need to have a methodology that everybody is copacetic with, that would describe those remaining lives, so we know that it may adjust your priorities on the pumpable, on the pumping and the decommissioning of those tanks over time.
Sure. So to your point of what the tie-up does or doesn't do for us, they advise us on the programmatic features we have, how we execute them, the frequency with which we inspect. They help us understand the results in some cases based on their expert knowledge of corrosion and NDE methodologies. They don't advise us on how long a tank will last. So it's really incumbent upon the data we gather to provide us that answer. So we gather UT measurements of the wall as an example to know how much remaining wall exists. And that's a future corrosion allowance, essentially is what that is for us. Then we take that information and share that on a periodicity with the IQRPE that's mandated by the WAC to judge the system's integrity and fitness for use, fitness for service. So the real answer, I think, to the question is that the IQRP dictates how long we have to operate the facility based on his comfort level with his or her comfort level with the information that we've shared as part of the program. So as good as our information is, it has to be enough and quantitative enough and broad enough to allow an independent party to look at the system and all the data we've gathered and judge that it's appropriate to use the system. And so your question, how do you go beyond design life, is we have to have enough data as part of our integrity programs to justify use and justify we haven't had a failure and justify we would detect the failure if it occurred. And that's what I think the programs serve for us and do, is they monitor for those conditions so we can mitigate them prior to through-wall penetration of a leak integrity failure, right? And that allows us to justify use of systems to an IQRP. Ultimately is the factor that judges whether we can operate the dangerous waste facility or not, which is the DSTs, SSTs, evaporator facility, ETF facility. Eventually the waste treatment plant as well will be in a similar ballpark, right? So that's the message, I think.
With the spalling on the single shell tanks, do you think
Excuse me,
that?
just 1 minute, because, just 1 second. So we're going to have a presentation at 11 o'clock. Jeff, are you able to present the IM advice at 11? And you can either enter into the chat or respond. So with this final, if there's any other questions after this, we'll take it offline. And I just wanted to also mention that for the meeting notes, if it's not easy to find, we'll be coming back to ask for the links for the monthly waste tank and summary reports and the assessments. Sometimes it turns into a scavenger hunt, but we'll present it. Okay, thanks. Rob, go ahead.
But my only thing is to ecology, in that, do you think that you need to revise the IQRPE analysis for the single shell tanks before 2030? Considering the findings of the spalling dome.
I am not the subject matter expert in that.
Yeah, Rob, we'll take that offline because we're really running late on time, and I will follow up and we'll follow up on that. But I know we're running super late, so.
And we have that noted. So Chris, if you want to tell us what it is, we'll be sure to include these last items in the notes and find a way to follow up. We're gonna break. We're coming back at 11, and the next agenda item is going to be the draft advice. So that's coming forward to all of the committees on the cleanup priorities for fiscal year 26. And then thanks to, Rob's accommodation, the committee business is going to be a half hour, still a good amount of time, but we've condensed that down a bit from the original schedule. And we can also raise any final points during committee business. So with that, we'll take a break. We'll see you back at 11. And let's show a little appreciation. This was
And thanks, Lindsay.
You're welcome.
Come. Take it away, Jeff.
All right, final two are taking their seats. Jeff, would you like to begin an overview?
Sure, thank you. So first off, apologies to people that saw this presentation yesterday. We're going to run through a lot of the same material, but I think hopefully focus a little bit more on tank integrity and tank waste issues today. So this is the 2026 cleanup priority advice that tracks DOE's 5-year plan goals. DOE sets out 4 different categories: core operations, waste treatment, risk reduction, and waste management. So our cleanup priorities fall into these 4 buckets. Would remind everyone that developing advice in the HAB is an iterative process. We're probably maybe 60% of the way through it. Everything is in draft form at this point in time. And a little bit about the schedule, so I don't forget it. We're looking for written comments. If you have something to put in an email to our HAB facilitation team by January 15th. The IM team meeting will meet again on January 23rd, and then we will present the results to the full HAB in our February meeting, either on the 6th or 7th. So next slide, please. Okay, we have currently items on 2 lists, the A list and the B list. So the A list obviously is things where we're pretty much in consensus. Some wordsmithing will be required and maybe some fine tuning, but there's been no substantive objections to things on the A list. The B list is where we do not yet have consensus. And that falls into a couple different areas. One is that vis-a-vis 2026, can we really pin down something specific for that year? So the other kind of bucket of things that end up on the B list is where somebody has a problem with the proposed advice, or it's just kind of not ready to end up on this particular IM team's advice. So an example of that might be right now, grouting. There's a lot of controversy about that. And are we as a HAB ready to take a position of any kind, in any way on grout? So those are the kinds of things that end up on the B list. So today we're going to run through these fairly quickly, again, focusing on tank waste issues primarily. So next slide, please. So this is what's currently on the A list. And I might add things on the B list. 3 different things can happen with them. They can get promoted to the A list as one of those 3 things. And based on our discussion yesterday, a DFLAW item that's currently on the B list will likely get promoted to the A list in the next iteration. What you saw a couple weeks ago with the meeting materials was revision 5, Rev 5. We're currently working on Rev 6. So that's what you're going to see today. You may have hard copy handouts of Rev 6, I don't know, but so that's what we're going to be working on today. So the A list, core operations, things like public involvement reporting. We will talk just very briefly about these. And one of the things about reporting that came to mind today in the discussion about DOE was someone asked a question, what have you guys done? What are you proud of over the course of the past year? And they definitely had something they like to talk about. Those are the kinds of things that we would like to see in more public-facing reporting. So HAB funding, workforce issues, those things are in core operations. Currently in waste treatment, there's really only one thing on the A list, and that's greenhouse gas emissions from the DFLAW facility. 2 larger categories are risk reduction that addresses things like the 324 building, fuel storage basin, groundwater protection, and rods at the 100 area. Waste management, the TRU waste, burial grounds, ERDF, orphan waste, and the fast flux test facility. Next slide, please. Okay, this is the B list where we're not at consensus yet. So I mentioned there's 3 different things can happen to things on this list. They can either get promoted to the A list, and the example there is the DFLAW operation. They can get dropped entirely, or they can get referred to committee. So some of these issues are complex enough, or they're not ripe enough to end up in a cleanup priority list or advice for 2026. So those are the types of issues that should get referred to, for example, the tank committee. So without, I think we'll pause just for a second here to see if there's any comments or questions, and would mention that what we're looking for today, because we have limited time, is substantive comments and concerns. Wordsmithing is something that still should be done in the IM team, but if you would like to do wordsmithing or propose new critical priorities, please do that in writing over the next week.
Just a reminder for those online, if you'd like to be in queue, please raise your virtual hand. Those in the room, please raise your real hand prominently so I can see it. Okay. Who would like to start?
Two questions. Any overview questions before we launch into this next piece on the actual advice? For those in the room and online, what you're looking at is the worksheet, and we'll be transcribing real time as the comments come in. So Jeff, how do you want to work through this list?
I'll walk through things pretty quickly, and as we go through them, if somebody has a question, that'd be great. I don't think we'll spend much time on core operations. That's kind of the purview of other committees, and we did discuss some of these issues yesterday in the joint meeting of the other committees. So if there's anything on core operations that somebody would like to comment on, now's the time to do it. Okay, moving on to waste treatment. The only thing that's currently on Rev 6 right now is greenhouse gas emissions, complete an assessment of CO2 emissions and mitigation alternatives for DFLAW. Any objections or comments on that?
Rob has a comment.
Yeah, one thing is that in the waste treatment, we should shadow the DOE's priority list as well for waste treatment. And that means initiate tank farm upgrades to support HLW treatment and optimize DFLAW operations through the extended hot commissioning. And I know that I'd sent you some comments before on that. I would like to include those. I think they're relatively important.
Okay, we will do that. One of those is currently on the B list. So when we get there, Rob, if you could address that once we get to the B list, because there has been some controversy there. Okay, could we next page, please?
We're on risk reduction.
Oh, sorry. Oh, okay, risk reduction. We've got here the 324 building, fuel storage basin, groundwater, and 100 area recreation. So is there anything on here that this committee would like to add or comment on?
And what you'll see in the room and online is on the right-hand side, comments that were made yesterday. So for example, on 324 building, check with EPA to see if this is already happening. These are just comments that were made yesterday. Does anybody have anything to add in on the risk reduction? We'll give you a minute to look at it.
So they were going to have it.
On the
Yeah, I thought we were going to go ahead and add it.
Yeah.
Not just comment on it, but they were going to add it to 324 building.
And
for the IM team.
right, so the recommendations are going forward. We're reporting, all of this is going to go to the IM team, and then the IM team will make its decisions on the 24th.
Okay.
Sorry about that. Spot on.
Yeah.
Yeah,
Well, we
thanks
can-
for clarification, Judy.
All right. Just regarding the comments, there were comments received on the fuel storage basin, and that we heard yesterday that the milestones indicated that this should be done by 2026. So the question to the IM team is, if that's true, does it stay as a 26 priority? That was one thing. And there was a discussion about the list of milestones. And then the other item under risk reduction was the deep Vado zone, and that there's a treatability study with preliminary results. Those results are expected to be released in 2025. And so of course, that process informs what happens at what time. Okay, so those were the items. Anything to add?
I think we added the cesium structure cap.
Cesium?
It's in the next section.
Yeah.
Okay,
So I think we are to waste management for you, Jeff.
So waste management, some of these issues are core interests of the tank group. So we talked yesterday about TRU waste. And this is one where the second half of that sentence, evaluate the disposition pathway of surplus low activity waste above the amount permitted for IDF disposal. That is something that Hanford Challenge objects to. And Mia, if you're still there, maybe you could elaborate on that. So I think this is the type of very important issue that's probably too much for this IM team and needs to get punted into your committee, for example. So.
Mia, would you like to provide some perspective or?
Yeah, I can, so this was the confusion and why DF law was put onto the B list when it should be on the A list. And Hanford Challenge's concern was with the second half of the sentence, which we believe is calling for grout without using the word grout in the sentence. And we will not consent to advice that is asking for grouting waste. So would like to see this removed and moved to the E list and out of the advice.
Okay,
Yes.
that's great. So we're not going to resolve that. We just want to make sure it's
Right.
captured.
And yeah, just to remind everybody, this is a consensus board, and anything on here that someone finds objectionable gets dropped off the A list into the B list. And that's just the way we operate, and that's okay. I see Chris's hand up.
Yes.
Yeah, I think we ought to move the first sentence, the first part of it, to the B list too. Expedite the certification shipment of true waste to WIP. Based upon the presentation yesterday, I'm not sure that we can expedite the shipment of things. I think that's already put in place through, I don't think we can go any faster than 2028. Based upon the presentation yesterday. So I think that needs some discussion, and I recommend we put it in the B list.
Okay, thank you, Chris.
Any other comments on this part?
Oh, and maybe there's really two different things here. Maybe a separate advice issue ought to be the one that Mia objects to, evaluate the disposition pathway. That's a little bit different than expedite certification of shipment of true. So I think there's two different things there, and maybe we ought to break them into two different possible advice topics and put them both in the B list.
Yes, I certainly understand that, and the second half of this is the type of issue that we would refer to another committee. Okay, anything else in the waste management list? And as you guys have some time to soak on this, you may come up with some other critical priorities, but just try to remember that we need to pin it to 2026.
And so the other items where there's been a sense of consensus is on the burial ground item, the ERDF element, orphan waste, and waste encapsulation and storage facilities. So these are areas where they feel that there's a sense of consensus. Did you want to move to the B list where perhaps there's less consensus?
Yes, I think it's time to do that.
Oh, and the fast flux facility. All right.
Okay, on the B list, this first item, based on yesterday's discussion, will get promoted to the A list. So is there any issues with the DF law item here?
I don't know if this is a wordsmith issue, but are you sure you want the word 20, the number 21 and not the number 30? And I'm intimately familiar where both of those numbers are from. 21 is the throughput, assuming that it's down 30% of the time, which is the WTP design basis. 30 is the nameplate, kind of normal on a day you're gonna make.
We used 21 because that was what was in the latest 5-year plan and DOE put down. So I think they want to reach 21 first, and then as time goes on, to try and optimize it up to 30. But 21 was what was in the latest 5-year plan, so that's what we put down.
Sounds good. My preference is 30. I think the plan either runs or it doesn't. And, but 21 is kind of a low bar. I probably would agree. I mean, I'm sure I would agree with the advice, whether bad either one. I just wanted to throw that out.
Okay, we will talk about that we might change the wording and add something like nameplate capacity of 30, but we will take that under advisement. Thanks.
Actually, I think in last year's advice, we used 30.
Okay.
Lower the bar. I mean, if you really wanted to lower the bar, I'd be ecstatic if they got 3.
All right, let's slide
Did you get that, Jeff? Ecstatic with 3.
Okay.
Okay, the next item on here had to do with Tisker waste, off-test waste that was generated recently, and the kind of where we ended up as an IM team was that should be resolved by 2026, and therefore that's an issue that would get dropped. Any comments on that?
So again, this TSCR item should be resolved by 2026, and the proposal is it's then moved for the fiscal year 26 advice because it should be done by then. That was the comment. All right.
Okay, the next item, disposition pathways for low activity in secondary vitrification waste. And the kind of the growing consensus on the IM team was that this is not ready for prime time. It needs to get chewed on by your committee for 6 months or a year before it ends. And you should prepare advice on this. We shouldn't set a marker in here unless it's something that you're very, very comfortable with and we can pin it to 2026. So please, comments, questions, in, out, what's your feeling?
Let's give people a minute to read it. And we're asking for your perspectives on holding and chewing on the disposition pathways further.
That come from Bob? This is Bob Quirk. I have a question. The permitted size of IDF. My recollection was granted, probably close to 20 years old, but IDF was supposed to be expandable, kind of like ERDF was. Is it permitted for the entire or just for the initial size of ERDF? Of IDF rather?
That's a good question. I'm gonna track that.
All right, so we have that question. It's been deemed a good one, and we will follow up on that. And if it's possible to get it just before the end of the meeting, we'll try and get your response. And if not, we'll circle back and include it in the meeting minutes.
Is a briefing like this on our schedule for this year? The idea briefing?
Lindsay?
I was gonna say the IDF question, I won't have a response during this meeting, so.
No, but I think the question was, is that perhaps on the list, and you're gonna say, you're gonna go back and see if it can be on the list, and if so, when it might be, is that right?
So I can take the action to take it back, but what I'm saying is I won't have a response to the committee during today.
Okay.
Would note that there is a past presentation on IDF that you might be able to review for some questions.
Was this last year, or do you have an idea of the year?
I'll find that date for you.
There's 2 different topics. That's saying a presentation on grout, which is on the work plan, which is, the latest was the soonest May, a presentation from the department. That's what Carrie said it'll.
Potentially, but it's, it's all up in holistic negotiations. There's nothing that we can share at this time. So we'll provide a briefing when it's timely and the agencies are committed to doing
Grout versus IDF. To me, those are 2 separate but connected topics.
And noted.
Thank you.
Okay, that's a good example of an issue that, given the time frame of this advice, doesn't cleanly fit in. And moving on to the last one, this one had to do with interstitial liquids, and the HAB in the past has issued advice on tank leaks, and some feel we should keep pounding that drum every chance we get. But we haven't been able to figure out exactly what kind of wording or what exactly we could put into this advice and pin to 2026.
Barney, did you say that there was, okay, I'll start.
This is also a good example of, Rob, what would you like us to put in here, if anything, on this issue?
Nothing right now.
Okay.
We need a presentation.
Okay, like, for example, I'm just gonna put down, this needs a presentation, right?
Yeah.
Okay, I think, yeah, we've run through the list, Judy.
No, please, here we are. It's up on your screen.
All right. There's more. Okay, the next one, it's another tank leak topic.
People are reviewing it, just so you know, Jeff.
Ryan?
Yeah.
You said that the tank leak response plan ultimately is gonna be in the site-wide permit, the latest site-wide.
That's correct, yeah, the leak response plan is gonna be incorporated into the Hanford site-wide permit, Rev 9 renewal. So when that comment period happens.
So is there, since the last part of this really deals with leak response to leaks, would you have any advice on how to rephrase that, given where that leak response plan is gonna go?
Well, I don't want to tell the board how to write your advice, so I'm not going to do that. But what I can offer, if it's helpful, is there was a question on the previous point here that said, what's the status of Ecology's request for a meeting with DOE to address the concerns raised and develop a path forward for a more complete response plan? I saw that question on there, so I followed up with my staff to get an answer, since I thought you guys might want to ask that today. And so what I heard from my staff was that we're currently working with Energy to revise the draft leak response plan, and both parties recognize it will be an ongoing process and not a one and done. We did have our first meeting before the holiday in December 2023 to address those concerns with both the program and legal teams in attendance. That meeting went well, and we're planning future meetings in the coming months as we exchange drafts and work on developing it further. And so I do also want to share that collaborative process was envisioned and required by the leak and tanks agreed order that was issued, and that it will result in a leak response plan that complies with the AO. So I thought that's kind of an update on that question of where our request was for a meeting with Energy.
So,
thanks, Brian. Judy, can you just capture what he said from the recording and make sure that's documented in our?
Yes, so I've got the key element here, and we'll go back from the recording and spell out a few of those details about the requirements that we need.
Yeah, and if there's clarifying questions, I'm happy to answer them, but I just want to be careful that I'm not telling you how to write advice, so.
When do you think the site-wide permit will go through all the rigmarole and be issued? After 2026 or before? Because
when it's issued, so we're still on track to issue the permit this year. I don't have an exact time frame, but what I've heard from our permitting staff is it depends on how many comments we get. It could take between a year to two to respond to all the comments and issue the permit. And that timeline is assuming we don't get an appeal on the permit. So assuming that timeline of we get the comments, we respond to them in that 1 or 2 year time frame, then, so let's just say the permit goes out for comment, this year, we'll respond to comments, so 2025, 2026, it could be issued hypothetically.
So if it's 2025 or 2026, we could still say, implement the segment of the site-wide permit that deals with leak response. And 2026 that might be a reasonable time frame to say something like that.
Probably could, yeah,
Okay.
it's just hard to tell right now, because we don't have the set firm dates yet for the comment period, so that's, the timing is just, it all depends on when the comment period happens, and then how many comments we get, and how long it takes to respond to those comments, so.
And you said the comment period should open this year
Yeah,
and then be addressed with it being issued in 25 days.
And
Okay.
a reminder,
Let's move on to mixed waste. My sense here is that with the possible exception of Chris Sutton, this is not an issue that Hab has spent much time on or is very familiar with. So the IM team has had trouble coming up with something, specific and actionable in this area based on our limited knowledge of that topic.
I think we need a presentation on this.
up here we have comments in the room or online.
I think we probably need a presentation on this from DOE sometime, maybe as a committee of the whole or something, but we need to learn more about what this is concerning with. Yeah, I think that's the best way to get it.
I don't think it's a tanks issue.
No.
Yeah,
Oh, yeah, I thought it was a farm issue.
yeah, Carm, yeah. Oh, it is.
Or lids.
Yeah.
Okay, we will refer that to CARM. The next one on here is low activity waste transport. And again, the objection there was that that's premature. No decision has been made and there's nothing other than the, what's that little pilot project going on. So this one seems to be premature. Is that your sense as well?
I don't think it's premature. I think, if you wait until you know about the program, you won't be able to influence it. But what I do think is this isn't a cleanup priority statement. This is how you clean up. And those are kind of different things.
Yeah, I think this is more of an advice
Yeah.
action as
Yeah.
opposed to a cleanup priority. I mean, the closest it goes back to is Richard yesterday saying with one of them that he would like to just make a decision on route, not influence yes or no, but he'd like to see a decision made, because until the decision is made, you can't move forward. But to me, this is more advice. It's more presentation, discussion, advice than it is a cleanup priority.
Okay.
Do you want tank waste to take that up? Do you think tank?
That could be lids in conjunction with tank waste,
Okay.
because I think waste transport is in lids.
So for this last item, perhaps partnering with lids and tanks, is that it?
Yeah.
Okay.
Sounds good to me.
So we're at 11:30. Jeff, do you have any closing comments?
No, well, thank you guys. This has been some very valuable input. So stay tuned for the next time you'll see it, either in the IM team or at the next HAB meeting.
No, we will have another session on this during the afternoon's meeting, I believe. And as a reminder, Jeff is seeking substantive comments. You can send those to hab@slind.net. That's SLIND.net. Also in the chat for this meeting.
And as a reminder, there is, after this meeting, this committee meeting will conclude after committee business, our final agenda item coming up. And then the community outreach and engagement meets this afternoon. And Before we close out, I want to remind us about a doodle poll for the February meeting, but feel like that's the line. Okay, so we are over to you, Rob, for committee business.
I have a comment first. You know, we have the LIDS committee, and the D stands for disposition. And I think there's a lot of confusion still on who is going to take ownership of waste. So yesterday in Carm, we had Tom kind of taking ownership of True, not LIDS. We have items here which is not clear whether Rob is going to do it or whether that should be in LIDS. And the whole thing of low activity waste, other kinds of waste, non-radioactive waste, we've heard nothing on that. So I think there needs to be some discussion, maybe when the executive committee meets, has a phone call on who exactly is going to handle the D. Is it really going to be LIDS? Is Carm going to do some of it? Is Rob going to do some of it? What is LIDS going to do about it?
And I can tell you that Richard has also weighed in, he didn't yesterday, but he has weighed in that waste disposition is in the statement for LIDS, and he has weighed in that that should be LIDS too. So I agree, it's a cross-cutting discussion that we do need to have to clarify responsibilities, where the lines are.
And with that being said, on the work plan for FY '24, we do have low activity offsite disposal identified as a topic that the agency will be presenting on, so.
But I think some of the discussion here led me to.
What type of waste is.
Yeah.
Right.
Because some of the things in there, well, is this Rob? Maybe he didn't know.
And that waste is why I said, Rob and Liz, because it's just like, you're right, it's not clean. We don't have a clean boundary lines yet.
It's not Rob.
Yes.
It's Twist. Or Twist or formerly Tank Waste. Yes.
Like a Twist, keep thinking of Twink.
No.
How about your septic waste?
So we're.
Okay, Rob.
Okay, just make it real close. We're gonna have elections coming up here this next, and we'll elect another chairman and vice chairman of this committee for an additional year or for a year's time. And we do this each year. I will throw my name in on the first ballot here. I've got a lot of stuff I still want to do here, people, right? And I think my term with the city will be, hopefully I can get another year. And that's kind of where I'm looking at. But we do have elections coming up. In March, and would like anybody that wants to participate in this, please let Pete have, first of all, nominate somebody. But before you nominate them, ask them if that's what they want to do. And then.
Rob wasn't even here when we elected him. Lonnie wasn't here, he might have said no.
So anyway, that's what we have coming out, so feel free. And if, I think you can make your nominations clear up to the time we vote. So if somebody in the last minute has got a lot of energy into something, please come and join us. I think this is a great committee. It is a bit on the technical side, and I've been warned that we need to make sure that any technical discussions result in a policy or looking at the policies. And so yeah, and we try to do that here. So the next question is out of what we heard today, are there any really burning questions that people want me to write down and then send over to Josh and Lindsay and try to get that as a subject either in our next meeting or the meeting after or the one in August?
Well, I think the cross-site transfer lines, that was one of the questions I had, sounded like it was gonna be put off. That would be nice.
Okay, and so we need to take that to our executive committee and determine whether that's a tank waste issue or whether it's an infrastructure issue with CARM, is it? No, LIDS. But it is involving corrosion, and it is involving looking at lifetimes and that sort of thing. Our advice is that we want to probably encourage a good thorough inspections of the pipe to give us a long lead time if we have to do replacements.
And Rob, I don't mean to interrupt, I just wanted to provide a reminder that it doesn't have to only be CARM or it doesn't have to only be the TWST committee. You know, there is the opportunity to have a joint meeting where we, you know, share topics that are of interest, you know, across multiple committees. It doesn't necessarily have to be that committee of the whole, but it can be a joint meeting topic or a joint meeting day. So just for your awareness.
And in talking with some others that, you know, we certainly expect, because that the cross-site transfer, the 70-mile line, the one we're gonna have to rely on to get waste from west to east in the evaporator is critically important. And it's been left idle for years. And it's very likely, it's got puddling in it and water in it. And on the bottom side, it's probably got some corrosion issues. And I think it's terribly important for us to make sure that, that we know that we're getting advice much in enough time that DOE can do something. And not hang up the rest of the site.
Okay, so we have a small queue building. We got Dan and then Chris. Dan, would you like to make your comment?
Almost afternoon. I'm not quite sure where to put it. It's the IDF, solid secondary waste. And Al Kruger actually shared this with me, is that the commingling of glass and grouted solid secondary waste is probably not a good idea. I remember in the performance analysis that it made a difference whether or not the glass and the grouted solid secondary waste were mingled. So I was kind of hoping we could take a good hard look at that, decide whether or not to advise DOE not to mingle.
Dan, I'm not sure why we're having a hard time hearing you. It's coming in muffled. Are you able to put the idea in the chat?
Yes, I am. Speaking of hard time, I'm having a hard time understanding that there's a lot of room noise, so I'm having a hard time understanding what's going on. I'll put that back.
Okay, thanks for that feedback.
And follow up to a previous note on IDF. The past presentation was provided to the River and Plateau Committee in August of 21.
Before my time.
Yeah, but it's online and can be reviewed. Chris.
One of the things that the comment I had, and didn't get to voice it, so I talked to Jason Gunter during the break, was to see if they had thought about using artificial intelligence as a tool to help with their tank integrity and tank leaks. Artificial intelligence, of course, is a buzzword, and technology breaks when we read about it all the time these days. But in listening to them talk about the tools they had and the tools that they're developing, it seemed to me that you could train a small database with observations from those tools in the years that they've been using them to be able to make an AI model to help them predict based upon that what sections of tanks are most likely to leak, how long a lifetime you might expect. There's a whole variety of things that they help them confirm their human observations or give input to the human observations. But I think it's a small database, relatively speaking. You're not using the entire internet to train a model. You're using a small database, and I think it would be easily doable. And I think they could get a lot of benefit from them. He said they're thinking about it, but they haven't started anything along these lines yet. But I think PNNL has an artificial intelligence group that is developing models. They developed one for groundwater in hexavalent chromium and use it to predict where flow is going to go. And I think if they let a contract to that group in PNNL, they could probably get something up pretty quickly, a model based upon all the observations to date and tools. And I think that'd be a good advice topic. It's good policy talk. We're not telling them how to do it or anything like that. We're just saying, this is a tool that we think might be available to help you in certain ways. Actually, DOE has an Office of Artificial Intelligence now in headquarters, and they're looking for ways to expand the use of that artificial intelligence throughout DOE. So this would fit into recent developments in DOE headquarters too.
So for work planning purposes, does that start as a presentation request?
You know, if we had a presentation request, it could be AI generally, how it could be used in DOE. Otherwise, I think maybe we could put it out as an advice, say, specific to tank integrity program. We could recommend that they look into this, and have a plan to how to utilize it. Not do it for this or do it for that, but is it worth, is it worthwhile trying to do it? Something like along those lines. We'd have to have an IM team to think about it. Where would the dividing line be between policy and kind of getting into the weeds technically?
And while Mia's in the queue, Dan, I just wanted to say, I think your comment was regarding IDF and secondary waste. I don't see it in the chat yet, and would love to be able to have it before the group here. Oh, there we go. Okay, so.
My first comment is related to that as well. I think, or I would like to ask for a briefing on specifically IDF and the permitted disposal capacity, and also this piece of preventing the exceedance of groundwater protection standards. And that's in regards to secondary waste being disposed there. Part of the reason why it's not in the advice is because it's something new that I had never heard of before, and we don't fully understand it. And then the other thing that's, so asking for a briefing on that. And then asking, and Rob, maybe you know more about the 242A evaporator.
Yeah.
We haven't had a briefing on that in a while. I know that it had an outage and there was issues with the freeze in last year. And I'm wondering if that's something I think the committee would be interested in learning about. It's a huge piece to the tank waste treatment mission.
There's a new campaign coming up this summer, right?
Yeah, and more on understanding the reliability.
Yeah.
Yeah.
We're writing all of this down, just so you know.
Thank you.
Very good.
So, I would second the 242 evaporator. The other one is, back in the old days, before we spent a lot of time re-envisioning how we're gonna function, every year we had a presentation on the system plan, and for some of you, the system plan is really what this group does. It's kind of puts together what the waste treatment mission for the tanks is, and I noticed that the new system plan came out, System Plan 10. I went and read kind of the first few pages of it.
Not to interrupt, Jacob, that's on the schedule for March.
It sure is, yes.
Oh, wow. Oh, man, see, I should look at this before I open it. There we go.
Make sure you come in March, because it'll be a good one.
Yeah. All right. I'm done then.
Dan's comment was for potential items, examine the advisability of commingling solid secondary waste from DFLAW and glass and IDF. So, do you need any clarification on that? That was his.
Well, other than we know that the filters and carbon beds and things of that sort, which are.
Send me an email on DFLAW, because we have Matt Irwin coming
Yeah. So.
in March, provide a briefing, so if there's any specific questions, you can shoot those over via email. I can make sure that Matt gets.
Sure, I'll formulate something.
Question, can you just flag in terms of what's coming up, what briefings are projected to be coming forward in March?
So two have been identified. One is that system plan 10. I would anticipate that's going to be a lengthy conversation that will eat up quite a bit of the agenda. Brian, do you concur with that?
Probably heard that, yeah.
Yeah, and then as well as a DF law. So somebody from Ricky Bang's team, if not Ricky Bang, will be here to discuss the system plan 10, and then it will be Matt Irwin coming to speak for DF law.
Would it be appropriate to submit some framing questions around IVF to go with DF law, or would that be a separate presentation request?
So you can submit them. Now, with that being said, I don't know that Matt would be able to, or will be answering those for what the focus of his briefing is. So if you're requesting a separate briefing on IDF, I would recommend that we kind of pause on those questions, just so then when we have somebody come in, they can, I don't want to say do it justice, but they can make sure that they're identifying all of those questions or addressing them during their topic.
So raise it, and it might go into the presentation, or they might know to be prepared to answer that question.
Yeah.
Who was speaking of?
I'll say, I know there was a question specifically today about the permitting capacity for IDF. I followed up with my permitting staff, and if I hear back from that, I can follow up and share with Lindsay and share with facilitation to distribute out and hear back on that.
Chris asked about Rob? Okay. Chris asked about an IM team. Does you, Mr. Committee Chair, do we want to charter an IM team to talk about or to look into AI? I mean, he threw it out there for suggesting.
Right.
It might be a little premature. I think it might be a better step to ask the folks at P&L who have the expertise in these modeling databases, how much data they need to create an effective model. Because one thing that I would worry about in the tank farm is we have one failed double shell tank that you can get data from. And that's, as Chris pointed out, that's a very narrow data set to work a model off of.
IM teams don't necessarily have to come up with advice. They can look at the issue and discuss the issue and see if it's worthwhile now, later, put boundary conditions about it. But we might consider an IM team dealing with grout too in some way, or the pest bed initiative in some way. But I think there's other IM teams that Rob could think about or ask about too. But the AI one is just, there's so much of it in the literature now, in newspapers, whatever. It just seemed to me like timing might be good. If you look down, if you want to have something in place down the road a couple of years.
It's not just one tank that's, I have a lot of data on pitting, especially at the air-liquid interface level. So I think they can look at that and maybe draw some points from that.
So my experience with AI is that it's totally driven by data. And if you have limited data going into an AI system, you can get an answer out of it. I could do it with 30 birds, pictures of birds, but it's no better than human decision-making at that point. To do tanks correctly would take hundreds of failures and thousands of non-failure tanks, probably even to compare with human decision-making. That's hard to swallow because it's supposed to be an intelligent thing, but it's not going to go out and get the data by itself. You have to put it all in there, into the storage, and let it analyze that data. Then when you put your test in there, it'll compare it with everything that's already in to give you an answer. And so I think that if tank data was available from more than Hanford equivalent tank data, it might be a start. If there's other facilities around the country that have tanks that maybe some have failed and others not. Yeah, but I really doubt that we could ever put enough stuff together to make an AI program that could give us some intelligent reading on, for instance, grout. It's not gonna happen. The human decision-making is.
Well, I'm not well. But I
Yeah,
think
but
you're
yeah.
right. My understanding is that algorithms have developed to such a point in AI now that the emphasis is on small models, small language
Well,
models,
small
limited
meaning,
data.
small meaning under 1 million entries, not 12, not 14. That's small. You know, Chat GPT, which I use regularly, has 175 billion
Yeah.
entries in it to do what it does. And I could fool the thing on a daily basis, you know? So you still have to have a big spread of data for that software to go through and compare this line with, you know, the next line. Computers don't look at pictures. They look at nothing but ones and zeros. And the same with data on pitting, you know, it doesn't look at pits, it looks at the data on that. So you have to have specific measurements of the pitting, and put millions of items in there for it to make a reasonable decision.
Well, part of my thinking is that the AI model that P&L developed for hexavalent chromium is based on a couple thousand results, and they've successfully been able to predict the same thing, that the group using the computer or the supercomputer, which runs for a week, they've been able to duplicate that. Just a couple thousand results that are in a HEIST database.
Yeah, and you know, I think that's not an isolated and a small item, hexavalent chromium, but there's lots of tests for it, you know, thousands. And so you could probably make an adequate choice.
So I've surveyed, part of the National Association of Corrosion Engineers has a database. And I was in it looking for lifetimes of carbon steel vessels, and seeing how long, even though they're designed for the 40-year life, how long they've gone. And there's one tank that has lasted 70 years, but it's in Minnesota. It's a straight water tank, and the utility is kept good stuff on it. Usually you don't see them. Other factors involved in that is corrosion has so many different influences. For example, the steels that they made those tanks out of, is it made to
If it's Korean steel or.
Well, no, it's not that it's Korean, it just has a different standard.
Yeah.
Okay, a different specification. And in order to do the corrosion studies that the group that they were talking about, the expert panel, they had to go out and procure a train car tanker that had been built at about the same phase. DOE bought it. Then they're using that as samples to represent the tank to do all the corrosion studies.
Right.
So there's so many other factors involved that I think it would be very difficult to predict corrosion failures.
And that's kind of what I was getting to.
On the other hand,
If I could interject just for a minute, being very mindful of time. We have Matt in the queue and Susan in the queue, because it sounds like this is like a complicated issue. So Matt?
My suggestion would just be that I might ask Lindsay or some of our, I just learned from Chris that there's an AI department at DOE headquarters. Perhaps we could reach out through this, get some information for them, maybe a presentation for them, and at the same time have our local regional experts that have worked on AI from P&L to come and give us a presentation. And if there's interest in moving forward with an IM team, then we can do it. I think we should maybe take a baby step first.
That's
So
a
I do
better
have that
idea.
request written down.
Okay, that seems to resonate.
I think we need an education before we make any kind of request.
Yeah. And we need to remember that we're supposed to give policy advice, not technical advice. And parts of AI would involve, you know, going out and getting data. Yeah.
All right, so Susan.
That's why I was, bring it full circle. Are we doing an IM team for AI or not?
No.
Chris, you okay?
I agree. I think we ought to know more about it first.
Make sure we wrap up committee business before, or 4 minutes are up. Sounds like 4 separate presentation requests, one for cross-site transfer, one for for DOE's IM department, the IDF, and 242A evaporator. Does that sound complete? And
Along with the other ones.
All the,
Yeah.
all the other ones.
Yeah. Yeah, she has a list from us already
Good.
for, fills us up for the year.
And so it might be helpful for the chair, you know, a prioritization, right? That what's the most important to make sure it gets covered and when, and that will have to be gone over offline, but there is a lot.
Yeah, and I
So
think,
we have a lot identified on the work plan for the TWST committee,
Yeah.
and so, I recommend that we start with what's on the work plan and see how we can incorporate some of this request into the work plan and go from there. But like I said, we said we can talk about this offline, and Rob, I can work with you and the other Rob to really outline things for the TWST committee for FY '24 as we continue forward.
and I think just to kind of wind down is that, there's a big job that Lindsay has to try to find people that can give the appropriate information, get a presentation prepared, do their dry runs, get it approved by management, and then show up here. And so, there's a lot more to it than just saying we want to learn about this. Give us a presentation.
Lindsay, is it still taking this long to get these things approved by Washington, the presentations?
It is, unfortunately. Some are quicker than others, and I can't quite figure out the rhyme or reason why, but.
Final comment for me, I'd encourage the committee to consider the framing questions for the confirmed presentations for March System Plan 10 and DF Law. Do you have any closing comments in our last meeting?
Go ahead.
Do you want to go first?
No, he's gonna wrap up, so this is a good time.
Well, I just wanted to share with everyone to check your emails. The facilitation team is going to be sending out a doodle poll. It's time sensitive. We are planning the HAB anniversary, 30th anniversary party for either Monday, February 5th or Tuesday, February 6th at 5 p.m. The evening of the Tuesday, if it were to be on that day, it would be at Chigueras. We still don't know for Monday where we would hold the event. So we need to find out your availability on those 2 days and see which date has more people available to attend. So around 5 p.m., just casual happy hour, you can order drink and food, and just a way to get together. So I think that will be going out maybe tomorrow.
Yeah.
And if you could submit it as soon as possible, it'd be really helpful to get planning and have things scheduled.
And I want to thank you for trying to organize this. This is a good thing. Thank you.
You're welcome.
Can we vote for both?
Yes, of course.
Yes.
That would be helpful too. Yeah.
We could
It's not
continue
either
it.
or. Just when you're available. If both days work,
Oh,
that's
okay,
great.
I thought we were okay. So,
Yeah,
okay,
sorry.
so we're both, yeah.
Yeah, there's some people that are not available on one day.
One day, it's not a popularity contest, it's
No.
an event available.
Any closing remarks?
I'm sure
I have
you
none, and I'm looking at Lindsay over here.
Okay, well, this meeting is adjourned. Thank you so much, Rob, and everyone for your attendance.
And back here in